Good morning to everyone. Hope everybody is doing fine. First of all, so a very good morning to all of you. So I hope you people doing great. And in yesterday's class, we have been discussed about. Let's start our class. So in yesterday's class, we discussed about the Bosniak's theory. And according to the Bosniak's theory, I have given you how the stresses are going to be varies with respect to vertical plane and with respect to horizontal plane. Now, if you see over here, the Bosniak's equation is going to be 3 by 2 pi into q by z square into 1 by 1 plus r by z whole square whole to the power of 5, right? But this theory is going to be, this equation is applicable for whom? Concentrated point load which is acting at the ground level. Concentrated point load which is acting at the ground level. So, according to Bosniak's theory, his theory states only the concentrated point load, and wherever you want to find out the point load stress, then you can use the Bosniak's theory. Now, there is a one more theory given by the Bosniak's, that is known as a for circular loaded area. See, at first he started with the point load, and then he has given many equations for line load and for circular loaded area also. He has mentioned some equations. So now let's see what are those equations. Now, second one, for line load. For line load, so far I have been discussed with you the point load. Now, for the same Bosniak's line load theory. So this theory says that again, if this is a ground level, so now if there is a line load acting on the ground level, see, line load means along the length. See, point load means at a particular point. Line load means along the length, and uniformly distributed load means over some area. So now let's see, a line load is acting on the ground surface perpendicular to the board. See, this is perpendicular to the board. This is perpendicular to the board. Whatever I am showing you is perpendicular to the board. So now, if this is a line load of Q, and this Q is going to be kilonewton per meter. The Q is going to be kilonewton per meter. And then, if you want to find out stress at any point, you see, whatever this is nothing but the depth direction, right? And this is a depth direction. You know, this is X direction. You know, this is Y direction. And you know, this is a Z direction. And now I want to find out a stress at this particular point. So from this, whatever the horizontal distance we have, if this is the point where I want to find out the vertical stress, which means sigma z. So now whatever the distance from here to here, let's take it as x, where x is the perpendicular distance. See, r is radial distance. Okay, r from that load you take any direction, this direction or this direction or this direction, whatever the direction is going to be the radial distance. Whereas x from the line of action, the perpendicular distance, where x is the perpendicular distance from line of action to point at which stress to be calculated. Point at which stress to be calculated. So here x is a perpendicular distance, which is this x here. X is a perpendicular distance from the line of action to the point at which stress to be calculated. See, if this is the condition, Bosnisk has mentioned again from his analysis, he has mentioned the sigma z is equals to. Now, can you please remember what is the equation given by Bosnisk for point load theory? For point load, he has mentioned 3 by 2 pi. 3 by 2 pi. See, 3 by 2 pi. See, I'll write you once again over here. For point load, it has been mentioned sigma z is equals to 3 by 2 pi into q by z square into 1 by 1 plus r by z whole square whole to the power of 5 by 2. That's the equation for the point load. And he has mentioned the same equation in terms of the line load by changing a small modifications. So I'm telling you, forget about the derivations, look over the concept. So now, in this case, what happens over here is, see, this equation is for point load. Now, in the case of line load, you observe, this is 3 by 2 pi, 3 by 2. 3 by 2 means 1.5, right? So 1.5 by pi. Now, whereas in the case of the line load, it is going to be 2 by pi. 2 by pi into, now you see, come over this portion. Come over this portion means I am telling you how to remember this. Come over this, what is this? Q by z square. See, the Q is kilonewton per z square means meter square. Yes, already small q is kilonewton per meter. So here capital Q kilonewton by z square means meter square. So kilonewton per meter square. Already small q is kilonewton per meter. So let's take it as a q dash, not small q. So let's take it as q dash. And now q dash is kilonewton per meter. So if you observe, then it is going to be q dash by z. What is q dash by z? Kilonewton per meter, kilonewton per meter square into 1 by 1 plus, this is r by z whole square, right? See, here r is a radial distance, and now which distance we are going to take here? X. 1 plus x by z whole square, 1 plus x by z whole square. Now, whole to the power of 5 by 2. Whole to the power of 5 by 2 means this is going to be 5 by 2, 2.5. Whole to the power of 2.5 here. Then here it is going to be square. So, what I want to say over here is, if you look over the equation, this equation is going to be almost similar to this is similar to the Bosniska point load theory only. According to the point load, he mentioned this is 3 by 2 pi, and 3 by 2 means 1.5 by pi. So In the case of the line load, it changes to 2 by pi into 2 by pi into q by z square means a q dash by z into 1 by 1 plus r, where r is a radial distance in the case of the point load. So where radial distance is going to be r, and here the distance is going to be x. So r by z whole square, x by z whole square, whole to the power of 5 by 2 and whole square. I hope in this fashion you can remember this equation. So this is the equation given by the Bosnisk, and this is for the point load, and this is for the line load. Okay. Next, third one, circular loaded area, and this is equation also given by Bosnisk. See, these are all the later modifications. These are all the later modifications. So at first he took care of point load, and then he got to know that point load is not a theory which is going to be accepted everywhere. So we have to look over the different type of loadings, because you know that when you apply load, the load can be a point load, it can be a line load, it can be uniformly distributed load, it can be uniformly varying load. So now the meaning of loaded area, circular loaded area. Area means load per unit area. Now it is going to be stress or pressure. See, this circular loaded area, he has mentioned the sigma z. What is meant by sigma z? Vertical stress at any depth z. Sigma z means vertical stress at any depth z is measured or is determined under the center line of circular loaded area. See, here Bosnisk, for every theory there must be some assumption or not. So here similarly, the Bosnisk says that you can find out the vertical stress at any depth, but under the center line of the loaded area. So now how does it look, sir? Now let me show you in plan view at first. Okay. So in the case of the plan view, you can see this is a circular loaded area. Circular loaded area. So when I say circular loaded area, which means it is going to be having an intensity of Q. What is meant by Q now? Kilonewton per meter square. See, you see, I'm giving you different type of loading patterns. Capital Q, kilonewton, point load. Q dash, kilonewton per meter, line load. Now, kilonewton per meter square, that is going to be loaded area, which means uniformly distributed load. So now, if this is a center, from the center, you know that whatever this is nothing but the radius, right? From the center, this is going to be the radius. So let's say R is a radius. R is not a, sorry, let me represent in a bigger view. This is a circular loaded area. Now, if you observe, this intensity of the circular loaded area is going to be Q, which is going to be kilonewton per meter square. Now, from the center, whatever the radius, this radius is going to be R. This radius is going to be R. So now, let's see how this is going to be helpful over here. In this plan view, this is a plan view, and in section view, how does it looks like? In section view, again, if this is a ground level, okay. So in the case of the section view, if this is a ground level, now okay. So this is a plan view. Now in section view, though it is going to be circle, in section view it cannot be seen as circle. It will be seen as some strip, just like a strip over here. Yes. So in the case of the section view, if you observe, you can see this one as a strip, and the intensity of this strip is going to be, you see, whatever, this is nothing but the uniformly distributed loaded area, right? So whenever I represent it in this fashion, then there is nothing but the uniformly distributed loaded area. And what is the intensity of this loaded area? Small q. So now you can see the difference between the different type of loadings over here. So if this is a circular loaded area, and where R is radius of loaded area. Loaded area means load per unit area. Loaded area means load per unit area. See, this is UDL, uniformly distributed load. This is a line load. So now, in the case of the uniformly distributed load, if you observe, see, along this length, everywhere the load is going to be uniformly distributed over some area. Okay. Now, let's see how to determine the stresses. See, this is going to be determined, sigma z is determined under the center line of the circular loaded area, under the center line of the circular loaded area. So now you observe, this is a center line. If you see carefully, whatever I am drawing, see, this is a center, and definitely this is going to be the center line. Yes, this is a center line. If you know the radius, you know this is nothing but the radius R, and you know the depth at which I need to find out. For example, let's say I want to find at a depth of Z. So this is the point where I want to find out the stress, and this is the radial distance, I'm sorry, this is the radius R, and this is the depth at which I need to find out the stress, which means, so you look, I want to find out sigma Z at this point. If I want to find out sigma Z at this point, now according to circular loaded area, what he mentions is, this is a center line, right? As it is a center line, this center line will make same angle with the both the edges of the loaded area. You observe? Yeah. If you observe clearly, so now you can see this one as whatever it is there on the both the sides, it is going to make a same angle. Let's take this as a theta. If I say this is going to be a theta, and now you please tell me if this is theta and is z r, then what about this value? Please tell me, come on. Array, this is r and this is a z. So r and a z, then the hypotenuse is going to be root of r square plus z square. Root of r square plus z square. This inclined is going to be root of r square plus z square. So now from this one, can I write cos theta is equals to what is cos theta? Adjacent by hypotenuse r square plus z square. And now further I am going to write this one as cos theta is equals to see, can I take this z to the denominator? If I take z to the denominator, then 1 by root of r square plus z square by z. Can I take inside of the root? Inside of the root, then I can write 1 plus r by z whole square. And I can write this one as cos theta is equals to 1 by 1 plus r by z whole square whole to the power of 1 by 2. So I hope you can understand this equation. 1 by 1 plus r by z whole square whole to the power of 1 by 2. Sir, but we want sigma z, sir. Yes, this circular loaded area, according to Bosnisk, this is also Bosnisk. So he mentioned that sigma z is equals to q into 1 minus cos cube theta. Q into 1 minus cos cube theta. So then what is the q over here is, if you look over here, so what is this q? Q is equals to cos theta. What is cos theta? 1 by 1 plus r by z whole square whole to the power of 1 by 2. That is cos theta. Then cos cube theta whole to the power of 1 by 2 into 3. 3 by 2. Can I write? Sigma z is equals to q into loaded area 1 minus 1 by 1 plus r by z whole square whole to the power of 3 by 2. Whole to the power of 3 by 2. So now this is the final equation. Yes. This is the final equation used to determine the vertical stress. See, in the case of the circular loaded area, according to Bosnisk, you can find out at any depth. This z can be 1 meter or 2 meter or 3 meter or any meters, but that line should be always below the center, which means a center line only. You cannot find out any other position. So you have to find out that sigma z under the center line of the footing, and if q is the intensity, then sigma z is equals to q into 1 minus cos cube theta. So this was the equation, and again there is a derivation for that. Don't worry about the derivation. I'm telling you again, don't worry about the derivation. Forget about the derivation. You don't need to look over the derivation. In this chapter entire, I am going to tell you what is the formula required for the load and what is the analysis. See, this chapter has questions comes from the equations only, not from the derivations. In this chapter, no derivation is required for you, and if it is there, I will definitely say you. So don't worry about the derivations. Look over the equation and what are the components in the equation and how we are going to apply these equations to solve the questions. Please have a look once. Proof is not important. Sir, is line and line load and UDL are same. Array line load and UDL, how they are going to be same? Line load is acting along a line, and UDL means over some area. You see the units of that line load and circular load area. See the units. This is kilometer per meter. This is kilometer per meter square. Good morning, sir. Please tell what subject after GT is going to be taught. When will aptitude and maths would be taught by ACE, as GT is our first subject in coaching. So I don't know what is the next subject that my dear student. So that will be let you know by the ACE team, not me. So I'm sorry for that. Circular load is same as a wheel load on roads. No, circular load is a different. See, earlier days, whatever the type of footings we used to construct is a circular footing. In the case of the oil foundation, in the case of the oil tanks, so oil tanks foundation is a circular load. Yes. What are the examples of concentrated point load and line load with respect to footing, sir? See, in the case of the, in reality, we don't apply any concentrated loads actually to say. Because in reality, whatever the load coming from the column is a point load. Understood? Whatever the load coming from the column is a point load, but while it is transferring to the soil mass, that load will transfer through the base of the footing. Through the base of the footing. See, though the load coming from the column is a point load, and through the base of the footing, that load is going to be passing through the base of the footing, which means load per unit area. Then it is going to be UDL. And what about this line load, sir? You can see the railway track, right? You can see the railway track along the length. So whatever the wheel load that you can see along the length, that is going to be the line load. So on one track, means on one rail, you can see that as a line load. Or I can say that train wheels are going to be two line loads working parallelly. Circular is a circular foundation is oil tankers foundation. So the circular foundation, and moreover that in the case of the footings also, we do have different shapes. Rectangular footing is there, and circular footing is there, square footing is there. Generally, we prefer the circular foundations in the case of the heavily loaded areas. In the case of the heavily loaded areas, why, sir? For a heavily loaded, like you see, whatever the machine foundations, oil tanks, means to the storage of the oil tanks would be there, where the weights are going to be more. We go for the circular loaded area. Why, sir? In the case of the square or circular, so in the case of the square or rectangular, at the corners, the stress variation is going to be very high. See, when there is a sharp corners, at that sharp corners, the stress variation is going to be very high. But if you see the circle, in the case of the circle, there is no sharp corners. As there is no sharp corners, then it can take the load uniformly, and the load is going to be distributed uniformly. In third condition, can't we find out the stresses other than points that are not lying on center line? No, you cannot find out. That's the condition over here. Some of our friends got mail that from tomorrow EE classes will start. As of now, I don't have any information regarding to that. So what I got to know is, up to this point, Line load is a compoundable example. No, it's not a compoundable example. It's see, we can see that strip loading later. So the sigma z is equals to q into 1 minus cos cube theta. These are the equation given by the Bosniska, not me. Sir, we can say Mr. Bajareddy. Sir, we can say wall load is an example for line load. No, you don't know. Means it's wall loading is a strip loading. You don't know that. I will tell you later. So keep that up. That line load means there also it is going to be, that is a kilonewton per meter square, but by taking length as a 1 meter. So please don't worry about that. Mr. Udit, which type of loading yields maximum sigma z, sir? See, it does not depends upon the type of loading. It depends upon the intensity of the loading, which means how much load is going to be applied. So you cannot say that exactly this load will give the most stress and that load will give the most stress. Is there any possibility to find out the stress in circular loaded area beyond the line passing through center? No, there is no possibility. That is a condition mentioned by Bosnisk. Sir, but train wheel loads are acting as moving load. Yes, they are moving loads, but I am not discussing about moving loads over here. I just told you those are two parallel tracks, and along the length of the track, the train load will act or not. So that's the reason why I told you it as a line load. See, I am not discussing the moving or static loads over here. If that load, whether it is moving or static, if it is acting along the length, then that is going to be the train load. Means okay, fine. So now I hope you have got this one. Sir, why, Mr. Kaushik, sir, why did you assume the line load into the ground level? I did not assume it, Kaushik. Bosnick assumed. You please go through the assumptions of the Bosnick. He assumed the load should act on the ground surface, whether it's a point load or line load or circular loaded area. And one more thing I'm going to say you. Yes, yesterday I have attached, I hope a lot of people, yesterday I have attached some files. So most of the people have attended this session now. So I'm telling you, yesterday you please, I hope everybody have gone through the files. Yesterday I attached an assignment for chapter number 7, 8, 9. And I have attached some 7 questions from these 3 chapters, because most of the concepts are going to be recurrence in the chapter number 7, in chapter number 8. The concepts are going to be recurring, and I have given you enough number of examples in the class itself. So I gave you 7 questions for you. You please go through that. And moreover that I gave you my short notes, what I have been prepared long back. So I made separate folder also over there, GT short notes. See, that is just for the sake of reference. Don't download or don't take it as a print to read the same thing. I might be have done something wrong over there. I might have missed some points. I gave you that for the sake of reference, how to make a short notes. So you can observe after downloading, it's going to be some 26 pages. So the 26 pages means 13 papers. Means one paper on both sides, 13 papers or 26 pages. So the entire geotech notes that I have written, I have made into some 13 papers and I have shared with you. That was given, means that was a thing that I have written in 2012 and 2013. So at that point of time, I have written on a papers and I took a screenshot and I have kept in a somewhere. So I got that and I shared with you. That is purely for the sake of understanding how to make the short notes. So do not try to copy the exact one. Try to make sure your short notes with your own hands, because when you make your short notes, then you can remember a lot of things. How many days more for geotech? How many days more means still we have completed half of the syllabus. So you people have to be wait for more time. Sir, is there any software for the analysis of soil? Yes, there are a lot of softwares. GeoStudio, GeoStudio. GeoStudio is a software, and Flaxis and FLAC, FLAC. There are a lot of softwares, so you don't need to worry about those softwares now. Okay, fine. So that's all with these conditions, and okay, let's see the next one. Now, Westergaard's theory. Westergaard's theory. See, coming to the Westergaard's theory, in the case of the Westergaard, he assumed soil exists as a stratified deposits with negligible thickness. See, in the case of the Bosnisk assumed soil is homogeneous and isotropic. But in reality, we know that soil will never be homogeneous and isotropic. So in reality, soil exists as a stratified deposits with a negligible thickness. So here, this soil, Westergaard's theory is going to be used in the case of the anisotropic soils. And the example is Warwood clay. Warwood clay. So now, one more assumption here is, according to Westergaard, concentrated point load should act at surface. Act at ground surface. Concentrated point load should act at a ground surface. See, you observe both the Bosnisk, the common thing in Bosnisk and Westergaard is, Bosnisk also assumed the concentrated point load and Westergaard also assumed the concentrated point load. So now, according to the Westergaard's theory, this is also a point load. You observe here, I am representing, this is going to be a point load. The meaning of concentrated means the point load should act exactly at the center. So, according to his equation, now sigma z is equals to, remember the Bosnisk equation, you please remember the Bosnisk equation, 3 by 2 pi. Yes, 3 by 2 pi, which means 1.5 by pi. So in the case of the Westergaard's, 1 by pi into their Bosnisk q by z square into 1 by 1 plus, in the case of the Bosnisk, r by z whole square. Now in the case of the Westergaard's, 2 times of r by z whole square whole to the power of, in Bosnisk, you know that whole to the power of 5 by 2. Bade miya, 5 by 2. And after the Westergaard's theory came, Chote Mia, now it is going to be 3 by 2. So let me repeat this again. Let me repeat this again. Sigma z is equals to 1 by pi into q by z square into 1 by 1 plus 2 times of r by z whole square whole to the power of 3 by 2. See, this is the Westergaard's and this is represents the point load theory only. Now, how to remember all these equations are? You please observe there is a common with the point load and the line load. Now, let's see. In the case of the Bose-Einstein, 3 by 2, 1.5, 1.5 by pi, and Westergaard's 1 by pi, and line load 2 by pi, into Bose-Einstein q by z square, Westergaard q by z square, line load q dash by z, into Bose-Einstein 1 by 1 plus r by z whole square, Westergaard's 1 by 1 plus 2 times of r by z whole square, and line load 1 by 1 plus x by z whole square, and whole to the power of pi by 2 Bose-Einstein, whole to the power of 3 by 2 Westergaard's, and line load is going to be whole square. So I hope you can remember these formulas. And again here, what is R? R means radial distance. R means radial distance. See, sir, if what happened? Are Mr. Anonymous attendee, why you are messaging these many times, sir? We are unable to see the short notes in website. Are how many times you message it? You please look over. I have created separate folder for the short notes. You please go through that once again. Okay, fine. I'll check that. I'll check and I'll let you know the short notes. Okay, I'll let you know that. Okay, fine, fine. You please listen the class. You please listen the class. You please listen the class now. We'll see it later. We please listen the class now. Okay, fine. So where R is the radial distance, see the entire theory. See the only difference with the Westergaard's and Bose-Einstein is going to be the difference is a stratified deposit. What is the meaning of stratified? Anisotropic, layered by layered. Whereas in the case of the Bose-Einstein, we assume it as homogeneous, and in the case of Westergaard's, we assume it as stratified. So note now. Though Westergaard's approach is more appropriate, but Bose-Einstein theory provides reliable results. See, though Westergaard's approach is more appropriate. Why I am saying more appropriate is he has considered, Westergaard considered the stratified deposit. So as Westergaard took care the stratified deposit is appropriate, but Bose-Einstein theory provide a more reliable results. So mostly we use Bose-Einstein theory only. Sir, what if they don't mention anything in the point load? For example, you observe in the given question, they are asking you to find out the vertical stress at a depth of 5 meters under a point load. See, point load theories are two theories. One is Bose-Einstein and other one is a Westergaard's. So which one I have to go for, sir? Which one I have to go for, sir? So for that, it depends upon the R by Z ratio. You see this one is right, R by Z ratio. Now, based on R by Z ratio, based on R by Z ratio, when R by Z is less than 1.5, sigma Z of Bosenisk is greater than sigma Z of Westergaard, and use sigma Z of Bosenisk. Use sigma Z of the Bosenisk. Similarly, when R by Z is equals to 1.5, then sigma Z of Bosenisk is equals to sigma Z of Westergaard. See, the B represents the Bosenisk and W represents the Westergaards. When R by Z is going to be greater than 1.5, then sigma Z of Westergaards is more than sigma Z of the Bosenisk. Then in this case, use sigma Z of Westergaard. So in the examination, how we are going to predict which theory we have to use, sir? It depends upon the R by Z ratio, sir. If you observe over here, based upon the R by Z ratio, when R by Z is going to be less than 1.5, see whatever the equations we have provided, Bosenisk and Westergaard, whatever the equations they have been provided. So on that equations, you know that as a sigma Z is a function of R comma Z. Sigma Z is a function of, again here also, sigma Z is a function of R comma Z. So based upon the R by Z ratio, if R by Z is less than 1.5, Bosenisk is more than the Westergaards. So you go for the usage of a Bosenisk theory, and R by Z is equals to 1.5, both are same. And if R by Z is going to be greater than 1.5, Westergaards is more. So whichever is going to be give some more value, you please take care of that value. This is a note point. This is a note point. So they can ask you, mostly whatever the situations we take, mostly the R by Z ratio is going to be less than 1.5 only. Mostly R by Z is going to be less than 1.5 only. So we use mostly whom? Bosenisk theory than the Westergaard's theory. So that's what the Westergaards and Bosenisk, these are about the point load, line load and circular loaded area. With this we completed two theories. One is Bosenisk theory, other one is Westergaard's theory. If R by Z is equals to 1.5, use any. You can use any of 2. You can use any of 2. Because both values are same, right? And Westergaard did not say anything regarding to the circular load or point, means line load. Sir, is there any experimental setup to justify this theory? What is the meaning of theory? The name of theory means based on assumptions. It's not experiment over here. So, what exactly is stratified deposits? Are you a new student? This is the one that I mentioned you. The stratified deposits means layered deposits. You please go to the previous chapters. I discussed 4 times the meaning of stratified deposit or anisotropic soil. Anisotropic soil. Does the pressure bulb exist for line load and circular load? Yes, they exist. Yes, definitely. Pressure bulb is going to be exist for all type of loadings. So you have to look over that. Yes, layered or stratified or anisotropic, all the deposits are same. So now let's start some other questions. We'll see that strip loading and all those things. Negligible thickness means the thickness is generally very less. They are not going to be meters and meters. They are going to be very small. See, if you have observed the excavation, on the side of the excavation or a face of an excavation, you can see there are a lot of soil layers which are going to having very small thickness like 10 centimeters, 20 centimeters, 30 centimeters also. So compared to meters and meters of depth, those centimeters are going to be negligible thickness. Now, let's see some of the problems. Okay. Now, come to the chapter number 10, stress distribution. So, you see the vertical stress distribution, this one. Observe the question number 2, question number 3. Yes. Question number 2 and 3. Everybody, have a look over the question number 2 and 3 now. Yes. This question number. A water tank is supported on 3 columns. A water tank is supported on 3 columns, which forms an equilateral triangle. See, in the plan view, there is a water tank, and that water tank is resting on the 3 columns. So in plan view, if I go for the columns, so there are 3 columns, column number A, column number B, column number B, and column number C. So there are 3 columns. This is a plan view, Nana. And if you see, all they are going to be attached as an equilateral triangle. You know the meaning of equilateral triangle. So they are going to be having a same size. And the total load of that tank is going to be from the top. The total load of the tank is going to be how much? 200 tons. See, let's imagine you are one of the column over here. And like you, 3 columns are there. So you and 2 other columns forms an equilateral triangle, and on the top of you total 200 tons. This is the load, total load 200 tons. The spacing between the columns is 3 meters. So for each and every column, this is going to be spacing of 3 meters. Assuming that load on each footing as a point load. Assuming that load on each footing as a point load. What is the meaning of that? Array, her column means in every column, what is the load? Point load. So in each and every column, there is a point load. Now, if you observe that point load, find the vertical stress in ton per meter square indicated at a depth of 2 meters. Under any one of the footing, use a Bosnian equation. So now they're asking is, you take any one of the footing, how many columns are there? 3 columns. And then how many footings would be? 3 footings. And what is the load carried by column? Point load. Array, total load is 200. And all the columns are going to be equally spaced. When all the columns are going to be equally spaced, then all the columns will take the same load or not, which means each column takes 1/3 of the total load. Then each load is a point load. Under any one of the footing, they are asking you find out the vertical stress under any one of the footing using the Bosnian equation. So now let's see. Classroom practice questions. Question number 2. Let's draw. See, these are the 3 columns. These are the three columns, and these columns are arranged in a equilateral triangle. I hope you can imagine this condition, right? I hope you can imagine this condition. So there are three columns. Now the total load acting over here. The total load acting over here. This is going to be total load how much? 200 tons. 200 tons. So now you see this is a column and this is a column and this is a column. And below this, whatever the load that is going to be transferred, they mentioned as every column has a point load, and every column is going to be takes a point load to the footing. Now you observe, you see all these footings, every footing is going to be having a same spacing or not. What is the spacing over here? 3 meters, 3 meters and 3 meters. I hope you are able to understand this one. So 3 meters. Now you observe here what is happening is every column has some load. Let's take this is column number 1, column number 2, column number 3. Now whatever this load is Q1, here this is going to be Q2 and here it is going to be Q3. So as each and every column is going to be same spacing, then as all columns has same spacing. See, this is a isometric projection. Whatever I have represented is isometric projection. So as all columns has the same spacing, then all the loads Q1, Q2, Q3 is equals to total load by 3, which is going to be 200 by 3, which is going to be 66.67 tons. 66.67 tons. So now, if you observe, so all these three loads are going to be represented in this fashion. Now what they're asking is, now I'll show you the section view. I'll show you the section view. So in the case of the section view, now you see okay, fine. So you please have a look over here. So if this is a ground level, now there are two loads, load number 1, Q1, and here Q2, and here Q3. So all the spacings are going to be same. Now I am asking you under any one of the footing, okay, under any one of the footing. So what they're asking is what is the vertical stress under any one of the footing at a depth of, see what is this depth? 2 meters. What is the sigma z under any one of the footing? So if you see here clearly, you see under any one of the footing, let's take, I can say this is the footing. Under any one of the footing, let's take this is the footing. This is z is equals to 2 meters. I can find out here. So you can take any one of the footings. Sir, why you're taking it one? I can take 2 and I can take 3. So under any one of footing, let's say column 1. Let's say column number 1. So now if you observe, I can say there are different type of stresses. How many are there here is, if you observe carefully now, yeah, see due to this load 1, due to the load 1 at this point, due to the load 1 at this point, there is a one stress, sigma Z1. And due to load 2, this load 2 will be at a distance of how many meters? Please, radial distance of 3 meters. See, for the load 2, what is the radial distance of this point? 3 meters at a depth. So now due to load 2, there is a one more stress known as, due to load 2, there is also one more stress which is going to be sigma Z2. And now you tell me here, due to load 3, this is going to be again 3 meters or not? So this is a 3 meters. See, at this point below, this Q1, due to load 1, there is a one stress, sigma Z1. Due to load 2, which is a 3 meters radial distance, again it has some stress. Due to Q3, again at a 3 meter radial distance, there is a some stress known as sigma Z3. So what is the total stress you can see over here is sigma Z1 plus sigma Z2 plus sigma Z3. Sigma Z1 plus sigma Z2 plus sigma Z3. You observe over here, every footing, see under footing 1, under footing 1, due to Q1, radial distance R1 is equals to due to 0. Due to Q2, radial distance R2 is equals to 3 meters. Due to Q3, radial distance R3 is equals to 3 meters. So this is what I want to find out, because ultimately what is the vertical stress according to Bose-Einstein? 3 by 2 pi into Q by Z square into 1 by 1 plus R by Z whole square whole to the power of 5 by 2. Whole to the power of 5 by 2. See, you know the loadings, you got the loading, yes, and you know the depth. What is the depth at which you are going to find out? 2. So I can take under point load 2 or I can take under point load 3. Whatever you take under that load, so you know that if the point of consideration and load acting is same, then radial distance is going to be 0. Yes. So for load Q1, this is Q1 and this is a point. So what is the radial distance over here? 0. But for Q2, what is the radial distance over here? This point is 3 meters away from the Q2 and this point is 3 meters away from the Q3. So now as R2 and R3 is going to be same, as R2 as Q2 is equals to Q3 and R2 is equals to R3, then sigma Z2 is equals to sigma Z3. So I can write sigma Z is equals to sigma Z1 plus 2 times of sigma Z2. So find out for sigma Z1 as R1 is equals to 0. Sigma Z1 is going to be written as 3 by 2 pi into Q1 by Z square. I hope you understood the meaning over here. So what is Q1? Q1 means 66.67 by Z. 2 square. You please find it out. Into 66.67 by 4. So which is going to be 7.958 ton per meter square. Similarly, you find out sigma Z2. What is sigma Z2? 3 by 2 pi into Q2 by Z square into 1 by 1 plus R2 by Z whole square whole to the power of 5 by 2. See, if you observe logically, whatever this one, you know that Q1 is equals to Q2 is equals to Q3 because as columns are same over here. So now if you observe over here, see this 3 by 2 pi into Q by Z square, this value and this value both are same. Then I can write directly 7.958 into 1 by 1 plus 3 by Z, 3 by 2 whole square whole to the power of 5 by 2. So sigma Z2 is equals to 3 by 2 whole square plus 1 by 1 whole to the power of 5 by 2 into 7.958, which is going to be 0.418. So now, after solving, sigma Z is equals to 7.958 plus 2 times of 0.418 is equals to 8.79. You can take it as a 8.8 ton per meter square if they ask with a single decimal. See, it's not about that solving. Solving can done by anyone, but it's about understanding. So I did not take much time for the calculations. For the calculations, I find out the sigma Z1 and I find out the sigma Z2. As I know that sigma Z2 is equal to sigma Z3, then I can write down sigma Z is equal to 7.958 plus 2 times of 0.418. It's not about solving the means calculations. It's about understanding. It's about understanding. I hope you understood this figure. So you take any point. This point has a radial distance of 0 under Q1, has a radial distance of 3 meters under Q2, has a radial distance of 3 meters under Q3. So the point you need to look over here is that radial distance. If you know the radial distance over here, then you can understand all this question. Please go through this. No, this calculations is difficult on multiple calculator. No, it won't be difficult. See, you can solve this one and you can directly multiply this one with this one. It's not going to be much difficult. Don't worry about that. Both forces are perpendicular. Mr. Swapnil, where the forces are perpendicular, right? See, first of all, you imagine this condition. You need to imagine this condition. You need to understand this condition. What is the meaning of this one? Then only you can apply. These type of models will not be accepted, expect in ESC prelims. They can be asked in ESC mains. See how R1 is going to be 0. Are Baba, why? How many times? What is the meaning of radial distance, Nana? What is the meaning of radial distance? You tell me. You see, means I will write this point separately. You observe for better understanding. You see, this is a load Q1, and I am finding the stress exactly below the point over here. So when the stress is exactly below, can I say if this is a ground level and I want exactly just below, then what is value over here? R1 is equals to 0. Okay. Now you observe over here. So I'll write down this is a ground level and here it is going to be Q2. But the point is where I want to find out at this depth. This is at a depth of 2 meters. So here sigma Z2 and where the radial distance is there. What is this radial distance here? The radial distance R2 is going to be 3 meters. So here radial distance R2 is going to be 3 meters. So that's what I represented over here. This is Q2 and this point is at a radial distance of 3 meters. And this is Q1. Under Q1, the load is directly under, see, under any one of the footing means, let's take column number 1. As I took under footing number 1 or under column number 1, the radial distance R1 is equals to 0. So can I take under Q2? Yes. If you take under Q2, then R2 is going to be 0 and R1 is going to be 1. Understood or not? So whatever this load over here, this load is going to be Q1. So whatever this load is going to be Q1, under Q1 here R1 is going to be 0, under Q2 here R2 is going to be 3 meters. Now I'll ask you one more point over here. These type of questions will expected in the case of gate. Yes. So now I'm asking you example number 2. If a water tank is rested on 4 columns as square configuration, Square means 4 meters, right? With spacing as 4 meters. The total load carried by water tank is 1000 kilonewtons. Then the vertical stress at a depth of 3 meters under any one of the footing is. The vertical stress under any one of the footing is. See, under any one of the footing I am asking you. So now this is you see, this is a triangular fashion. Now I am going to represent you the square fashion. So if I represent the square fashion, you please tell me what is going to be happen. I hope you understood by this point. I hope you understood. See, one more point I want to conclude over here is, you see, under Q1 as radial distance is 0 and at this point stress is more. But due to Q2, this is radial distance, right? As radial distance increases, stress is going to be decreases. You see, when radial distance is 0, what is the stress? 7.958. When radial distance is going to be 3 meters, what is the stress? 0.418, which means as radial distance increases, stress is going to be decreases. So now I'm giving a homework for you people. This one, so this is a homework for you. I'm not going to solve this one. So you please try to find it out, and you know what to solve. And I'll be giving this just the figure. So please you try to understand the figure. Now you observe. You see, this is a water tank which is going to be rested on the 4 columns now. So now you see what is the total load. What is the total load acting over here? The total load is going to be 1000 kilonewtons, and each one is going to be carry a point load. So let's take column number 1, 2, 3, 4. So and each load Q1, Q2, Q3 and Q4 and Q3. So this is the condition. Now under any one of the footing I am asking you, right? You know that the spacing between everything is going to be, what is this? 4 meters. Yes. So now you please observe here. This is Q1. So now you know that the spacing between any footing is going to be 4 meters. This is a 4 and 4 and 4, and even this is also going to be 4 meters. Now I want out the stress under any footing. So at Z is equals to how much? Z equals to how much I have given? Yes. So Z is equals to 3 meters. When Z is equals to 3 meters, at this point, what is the vertical stress? See, if you understand the concept is crystal clear for you here. The concept is crystal clear for you here. So now there are 4 stresses. You please go through this question. There are 4 stresses. So, and I want you see for this one, see under footing 1, what is R1? R1 is equals to 0 because below the load the point is going to be there. And what is R2? You see R2 now. What is R2? See, this is a Q2 and this R2 is going to be due to this one. See this point. What is the radial distance over here? The radial distance is going to be 4 meters. And what about R4? R4 you see here. This R4 is going to be radial distance of 4 meters. And what about R3, sir? Now you see, sir. What is R3, sir? This is 4 meters. What is R3, sir? Now R3 is going to be from this point to this point, whatever the radial distance is there. This is R2 and this is R4 and this value is going to be R3. So what is R3? Root of 4 square plus 4 square, which is nothing but 4 root 2 meters. So under each and every footing, you please go through that. Under each and every footing, for Q2, what is R2? 4 meters. For Q3, for Q4, what is R4? 4 meters. For Q3, what is R1? I mean R4. Yes. What is R3? This is going to be 4 root 2 meters. Now, if you know this one, then you can find out the values. So you please go through this one. You can find out sigma Z is equals to sigma Z1 plus sigma Z2 plus sigma Z3 plus sigma Z4, and I can write sigma Z2 is equals to sigma Z4. So you please go through this one and you please try to solve it, and I'm not going to be solving that. So I'm not going to solve it further. So please, I explained you this point. You please go through this once again. I'll give you the answer during the break. After the break, means not now. You, if you wanted, you take a screenshot and Mr. Kaushik, sorry, given in a higher polygon fashion, they won't give that a complexity, so don't worry about that. If they ask at center directly, then all the radiations are going to be same. Please have a look over here. So now we'll go for the next topic. Why sigma 2 is going to be sigma 4? Okay, fine. You please find out all these things also. Why I won't give you. You please find out all those things. Why you are asking sigma Z2 is equal to sigma Z3? अरे क्या रे भाई? अब देखो ना इधर. ये क्या है इधर? R2 और R4 क्या है? दोनों 4 meters है ना? Still, if you don't understand, I cannot do anything, because I'm going to write down one more time over here. This is Q1. Here this is Q2. Here this is Q3, and here I'm going to provide you Q4. So now under any one of the footing, you see, I want to find out the stress over here. You observe, I want to find out the stress over here. So now you tell me, as a point is directly under load 1, directly under load 1. So under load 1, what is the radial distance over here? Due to this load, what is the radial distance over here? 0. R1 is equals to 0. So I hope you understood that. And now, if you see that due to load 2, what is the distance between load 1 and see, what about this point? What is the distance over here? R2 is equals to 4 meters. And now, due to load 3, now this is Q3 and this is going to be Q4. So now this R2 is equals to 4 meters. Now similarly, you see this one. From this point, what is the radial distance over here? You know this is 4 and this is 4. Then what is R3? R3 is equals to 4 square plus 4 square root, which is going to be 4 root 2 meters. And for this point, what is R4? R4 is going to be 4 meters. I don't think anyone can explain this much simpler. This is the values. You please solve these ones, then you can get it done. Mr. Gaurav, sir, yesterday's point load case is different. In today's case, load at radial distance is influencing. Yes, load at radial distance is influencing. Yesterday's point load is not different. You please go through that. I say the same way. But yesterday load is applied at point under consideration and stress is calculated at radial distance. See, load is up where there is a load, but you have to find out the stress where under the consideration, right? And if that point of consideration and load is same, then radial distance is 0. If the point is away from the point load, then the rate relations comes into the existence. So if you have answers, you please keep it. I am going to give you answers after the break, not now. Definitely I'll give you the answers. So please yes. Okay. So that's all with this. Now we'll go for the next question, classroom practice question. If you see the next classroom practice question, question number 3. Everybody have a look over the question number 3, please. A circular ring type foundation for a water tank. I told you circular type of foundations will be applied for the water tanks or oil tanks. Exerts on a soil a uniformly distributed pressure of Q. What is meant by uniformly distributed pressure? UDL, loaded area, Q is equals to 20 kilonewton per meter square. The outer and inner radii of a ring shaft are 4 meters and 3 meters respectively. So there is a ring. The ring is going to be looks like this one. The ring is going to be looks like this one. So the outer radius and inner radius. There is a outer radius. What is outer radius? 4 meters and inner radius 3 meters. Then the vertical stress at a center of the foundation at 10 meters depth is the vertical stress at the center of the foundation at 10 meters. See, they're asking where at the center of the foundation, the vertical stress at the center, which means is it a center line theory or not? Yes. Given a circular loaded area and they're asking the stress exactly at the center line, which means Bosni's theory comes into the existence. So now let's go back. I hope you people are able to understand. So there is a one circle. Yes. So this is a ring type foundation. This is a ring type foundation. And you can observe from the center, you can see this is the inner radius. And you can get this is the outer radius. So this inner radius R inner is 3 meters, R outer is 4 meters. So now I want to find out the stress. See, this is a plan view. This is a plan view. In the case of section view, I can show you here. In the case of the section view, this is going to be the strip we can observe over here. But the point is there is a no load portion between over here. No load portion between over here. Okay. Now the question is, see, I gave you the Q value. What is the Q value I mentioned you? What is the Q value I mentioned? Yes, the Q value is going to be 20 kilonewton per meter square, and I am asking you to find out the vertical stress at a depth of 10 meters. So I'm asking you exactly vertical stress at a depth of 10 meters under the center line. Z is equals to 10 meters. So now what is the question here is, for circular loaded area under center line. See, have we discussed about you observe, have we discussed about the solid circular loaded area or hollow circular loaded area? Solid. We discussed about the solid circular loaded area, but given is a hollow, means a ring type, yes or no? So what I do is, at first I fill this one entire. What I do is, remember everyone, please remember, please listen over here. What I do is, I take the whole circle. I take the whole circle, means I fill the circle also. Then what I do is, once I make this one as a solid, I find out the stress due to this whole solid. Then if it is a solid, then what is the whole radius? 4 meters, which means outer. Yes or no? Now, once I find out the total stress, then what I do is, whatever the adding portion, this is the adding portion or not? So this adding portion of dia means radius how much? 3 meters. So now first I find out the solid circle of radius 4 meters stress, and then I find out this inner circle radius of 3 meters. Now out of the total stress, if I remove the stress due to inner circle, then I can find out the stress, because whatever the equation I have, that is for the solid. So for that, what I do is, for that what I do is, I don't have any theory for that. So for that what I do is, I can take the sigma z as, first I consider the vertical stress due to the outer minus vertical stress due to inner. So I can take the vertical stress due to outer and I can take the vertical stress due to inner. So as simple as that, when I take outer, so total stress due to outer, I can find out the total dia. So I'm now you see, this is outer, this is going to be inner, this is outer and this is going to be inner. So now what is the outer dia, please? Okay, so now if you see, this is R outer 4 meters and this is R inner, which is going to be 3 meters. So find out the stress due to the outer and find out the stress due to the inner. So from the outer, if you remove the inner, then whatever the space left over, this is the space left over, that you can find it out. So now okay. So as you know, sigma z is equals to q into 1 minus 1 by 1 plus r by z whole square whole to the power of 3 by 2. So sigma z is equals to q outer. What is the q value given? 20 kilopascals. 20 into 1 minus 1 by 1 plus r outer 4 by z 10 whole square whole to the power of 3 by 2. Sigma z inner 20 into 1 minus 1 by 1 plus 3 by 10 whole square whole to the power of 3 by 2. So I am taking a lot of time to make you understand the concept. Whole square plus 1 by answer whole to the power of 3 by 2 minus answer into 20, which means this is going to be 3.99 kilopascals, means kilonewton per meter square, and 3 by 10 whole square plus 1 by answer whole to the power of 3 by 2 1 minus into 2. This is going to be 2.425 kilopascal. See, if I take the whole outer, this is the stress. If I take whole inner, this is the stress. But this is a ring which is going to be outer minus inner. There is no area in the inner, right? So now I can find out sigma z is equals to 3.99 minus 2.425. which is going to be 1.56 kilopascals. The answer is going to be 1.56 kilopascals. The answer is going to be 1.56 kilopascals. So that's all about the question. Please have a look. 1 minute. So. Sir, why inner circle don't have area, sir? Sir, please, sir. This is a ring, re baba. Ring means hollow. Inside, this is hollow, right? Inside, this is hollow. Is it a solid circle or a hollow circle? Hollow, right? You have you have ring for your finger, right? You take that ring outside and you can see that is hollow. That hollow portion will not apply any stress. This hollow portion will not apply any stress. This portion only, whatever this portion only will apply some stress. This is the ring portion will apply some stress, not the hollow portion. So in order to find out this, the simple logic is I go for the outer minus inner. Just like donut. Okay. So now you next go for the next question, please. Yes. You see next question number 6. Question number 6, please. Yes. Okay. So now, if you look over the question number 6, this is question number 6. The flexible area shown. Okay. For this one, now we need to go for the next topic. We'll see this one after the next topic, but as of now, see this one later. So can't we take effective radius? No, Kaushik, we cannot take the effective radius. See here, not only R, Z is also going to be effect, so you cannot take the effective radius. We calculate stress for the inner ring also, sir. Yes, we calculate and then we remove that, right? Just simply, you see one logic over here. If there is a nothing mentioned, you find it out and you remove it at the end. You find it out and you remove it at the end. So now you are going to see the same thing. So let me discuss about next topic. Next. Newmark's method So in the case of the Newmark's method, and again, see in this chapter, for every method I am going to discuss, there are some assumptions or there are some conditions. You have to apply those conditions only. Next, this is a suitable to determine vertical stress at any depth for rectangular loaded area only. For rectangular loaded areas only. Rectangular loaded areas only. So this is a Newmark's method. The Newmark's chart is also there. We'll be discussing the Newmark's chart later. So that will take some time. So that's the reason why I have given you the Newmark's method. So this is suitable for rectangular loaded area only. Now let's take a rectangle and see this is a rectangular loaded area. And when I say loaded area, what is the meaning of loaded area? You know that. Loaded area means Q. What is Q? Kilopascal. Let's take L is the length of the rectangle and P is the width of the rectangle. So in the case of the plan view, it looks like this one. And in the case of the section view, so now you observe here, in the case of the section view, yes, this is a rectangular loaded area of intensity Q. So the intensity is going to be Q. And again, there is a condition for here. The condition is a point at which stress to be calculated. Should always consider as corner of rectangle. See, this is very, very, very important. Should always consider as the corner of the rectangle. So you observe over here, it should be considered as always corner of the rectangle. So wherever you want to find out, you can find. You can find out inside or outside or at the line or at the boundary. You take any point, but that point should be considered as a corner of the rectangle. Sir, how it is going to be possible, sir? Now let's see. Let's first take condition A. Condition A at the corner itself. See, I take the point itself as a corner. So the point at which stress to be calculated should always consider as a corner of rectangle. So that's the reason why I'm taking the point directly itself as a corner. So if I take the point directly itself as a corner, see, this is the point. Let's take this as a point A, which is nothing but this is the corner A or not? Yes. So now I want to find out stress at this corner at some depth Z. So what is the vertical stress at this depth Z? What is the point over here? This is a point A. So at a point A, now I took the point directly at the corner. So let's see how I can explain this thing. So at corner A. So I need to find out the stress. So for that, in the case of the Newmark's, in order to find out the sigma Z, he has given an equation I into Q. I into Q. You see, this is an equation. This is an equation. You see here, this Q is going to be constant. Yes or no? This Q is going to be constant. So for a given rectangle, this Q is going to be constant. Whether you split it or whether you multiply it, the loaded area is going to be constant because that is the pressure acting on the soil mass. And now this sigma z is entirely depends upon sigma z entirely depends on whom? I, where I is an influence factor which depends on m comma n. Sir, what is this m comma n, sir? What is this m comma n? So you please look over here. This m comma n are ratio of dimensions of rectangle to depth. Ratio of dimensions of rectangle to depth. Sir, what is the meaning of this one, sir? The meaning is going to be, you observe, this I depends on m and n. And I told you just now, ratio of the dimension. See, if this is the point, this point, I took already this point as corner, right? Already I took this point as a corner. So then you tell me, please, what is the dimensions? So at this point, for this point, this is a rectangle. And what is the dimensions over here? L and B. The dimensions for the rectangle for this corner point as L and B. So now, if this is going to be L and B, so the ratio of dimensions of rectangle together, what is the depth over here? Z. L by Z. B by Z. Sir, should I have to take M as always L by Z? No need to be. M can be B by Z or L by Z. So that's the reason why I told you ratio of dimensions. How many dimensions are there? 2 dimensions are there. One is L, other one is going to be B. There are 2 dimensions. For these 2 dimensions, the dimension ratio to the depth gives 2 coefficients m comma n. So this I value depends upon the m comma n. That's simple. Sir, I can find out m and I can find out n, but how to find out I, sir? So for this Newmark provided a table the table consists of this is a Newmark's table. This table consists of, you see, you find out m. What is m? What is m? L by Z. You find out n and you can get the I value. In the examination also, they will give you the mn. Sorry. In the examination also, they will give you this table. In examination also, they will give you this table. So you have to find out m and n, and you see the table and you get down the I value over here. See, in examination, they will provide you the I value, but you have to find out m and n. So once you find out m and n, then you can find out the I value. That's as simple as that. Nothing is going to be there. So this is at a corner directly I took the corner, so nothing changes. This is the corner, these are the dimensions. Now there comes the actual. What if yet center? What if yet center? So now if I ask you at center, you please, so let me draw, I will draw the other figure also, so that you don't need to consider yourself into the ambiguity. So now at the center, I want to find out at center. So let's take the same length L, width as B, and same the Q kilopascals. But now my point is at the center. So if I ask you at center, come on, now there comes the actual thing. See, whatever the point at which stress to be calculated, should always consider as a corner of rectangle. Should always consider as a corner of the rectangle. So now my point is this one, but what is this actual point? Center. So I told you, you have to consider this point as a corner of rectangle. Then how come I make sure this point as corner of rectangle, sir? Think. How come you make sure this point as corner of rectangle? Yes, you tell me. So now if I can make sure this one as divided into 4 equal rectangles, now you see if I divide it into four equal rectangles like this. Now you observe, I want the point at which I need to find out should be over here as so this one. So now the portion that I am going to show here is this is the portion. So I want you to look over here, please. Yes. So now what I have done is I took this entire circle, means this rectangle, but I want the stress at the center. So as I want the stress at the center, so what I have done is I divided this into equilateral, means divide rectangle into 4 equal parts, so as center would act as corner for all rectangles. For all the rectangles, the center would act as a corner of the rectangle. So now you see, what is the dimensions over here? Now you please tell me, what are the dimensions now? Does the dimensions are going to be L and B? No. What is this dimension? This is going to be L by 2 and this is going to be B by 2. So this is one rectangle, this is one rectangle 2, and this is 3, and this is going to be 4. And each and every rectangle will have some stress at the center. Yes or no? So now you please tell me, so at this corner, you please observe, for every rectangle, now I can say the sigma z is equals to sigma z1 plus sigma z2 plus sigma z3 plus sigma z4. As you know, sigma z is equals to I into Q. Now, sigma z is equals to I1 plus I2 plus I3 plus I4 into Q. Because the discharge means the value of stress is going to be same. The value of the stress is going to be same. As the value of the stress is going to be same, it depends upon the I value only. Yes or no? So now, as you know, I depends on M comma N. Yes or no? I depends upon M comma N. And as I depends upon the M comma N, and Mn is going to be dimensions of ratio of dimensions of rectangle to depth. So as all rectangles has same dimensions, I value would be same. I value would be same, which means I1 is equals to I2 is equals to I3 is equals to I4 is equals to I dash. So now I can write sigma z is equals to I dash 4 I dash. Sigma z is equals to 4 I dash into Q. So yes. So sigma z is equals to 4 I dash into Q at center. And how to find out this I dash, sir? Sir, this I dash, you know that I dash depends upon the now M comma N, and this one depends upon L dash by Z and B dash by Z. See, what is this L dash, sir? L dash is going to be L by 2. B dash is equals to B by 2. So what I have done is, I'm not changing the form. I'm not changing the form. I'm not changing the form. The form is, it depends upon the ratio of dimensions. So for one rectangle, now what is the dimensions? The reduced dimensions are L by 2 and B by 2. So instead of writing L by 2 by Z and B by 2 by Z, I write L by Z and B by Z. What is L dash and B dash? L dash and B dash are the dimensions of the small rectangle, where L dash is equals to L by 2, B dash is equals to B by 2. L dash comma B dash are dimensions of small rectangle. So I hope you understood this over here. Let's have a look. Mr. Anonymous attendee, one of the persons continuously asking, sir, is this important for gate? Is this important for gate? You shut up your mouth and listen to me. Okay. If it is important for gate, then only I say. If it is not important, I won't spend more time for that. So do not ask me these type of questions again and again and again. When I say, listen, that's it. And if you have a doubt regarding to the subject, you ask me. Sir, is it important for the gate or not important for the gate? As it is important or not important, I say, because I know. Do you know? Have you written the examination previous and then previous years? So don't ask these type of questions. How to calculate I value? Are Baba, after all discussion, you are asking the same thing. This is a Newmark's table. Once you know the M value and N value, you can get down the I value from this one. So this, once you know M and N, you can find out the I value. So now I'll say one more condition over here, please. With this condition, we'll complete because you observe, I took a point at the corner and I took one point at the center. Sir, what if the point is not at center? If the point is not at center, if the point is somewhere over here, then also you divide into four rectangles. But now those dimensions are not going to be same. You have to find out I1, I2, I3, and I4, and everything. You need to find it out. So now, what if the point is outside? What if the point is going to be outside? See again, there is a rectangle and its usual dimensions are L and B. The usual dimensions are L and B and Q kilopascals. So now I want to find out the stress at this point, let's say. At this point, now the point is the A. So how to find out this stress? See, you can take anywhere. Sir, I will take this point over here, sir. Or I'll take somewhere over here, sir. I'll take somewhere over here, sir. It's up to you, sir. I told you, in the case of Newmark's method, you can find out inside, you can find out on the, you can find out outside. So now let me take over this point over here. Yes. So let me take this point A. So I want to find out this stress. As you know, the point is outside. Arisa, the point is outside. But you know that the point at which stress to be calculated should always consider as a corner of the rectangle. So I need to consider this point as corner. Then what I do is extend a rectangle to the point at which stress to be found. So just you extend the rectangle. Sir, how come I extend the rectangle, sir? Now you see, sir. I can just extend the rectangle over here. Okay. So now you please observe, I am extending the rectangle over here, but this portion is not actually included. But what I am going to do is I am extending. So let's say the extended length is going to be L dash. And is there an extension in the width? No, no change in the width, but the total length is going to be now as a L plus L dash. So now what is the total length over here? The total length will become L plus L dash. So now you tell me, I need to find out the stress over here. So first, when I extend this, then this point is going to behave like a corner at the rectangle or not? Yes. So now sigma z is equals to, let's take it as a sigma z1, which means our total, or sigma z of total. Now, but what is the actual figure over here? The actual figure is going to be this one. Whatever the shaded portion is the actual figure. But this is the extended portion or not? Yes or no? So now, first I find out the total. First I find out the total. Then I remove the extra added. So first I find out the total. Just now in the previous one, I discussed about circular loaded area, right? In the case of circular loaded area, first I took the total and then I removed the hollow portion. Yes. Similarly, here also first I'll take the total of rectangle, which width is going to be B and length is going to be L plus L dash. Then whatever the extra I added, this is a rectangle, right? You see what is this rectangle, dotted rectangle over here? This rectangle of length L dash and width B, also that is also going to be act as a corner, right? Now you find out the extra added. So I can write sigma z is equals to I1 into Q minus I2 into Q, which means I1 minus I2 into Q. Sir, how to find out I1, sir? I1 depends upon M1 and N1. What is M1 over here, sir? L plus L dash by Z. What is N1, sir? B by Z. Similarly, what is I2? This is for whole. For whole, and this is a extra portion. What is extra portion here? B and L dash. So I2 depends upon M2 and N2. So L dash by Z and B by Z. So this is the condition that I am going to discuss. So don't think here L dash and L by 2 both are same. Don't think this and this value are going to be same. No, not at all. They are different. They are entirely different. So that's all with this topic. So we have find out initially inside, outside. Now the summary is simply wherever they give the point, consider that point as a corner. If the point is outside, extend it. If the point is inside, divide it. So when you extend it, you can find out the total minus extra. You please find out the M1 N1. Once you know the M1 N1, you please go through here M1 N1. You find out I. So once you know M2 N2, you go to the table. You can see over the M2 and N2. You can find out the I2. So that's all with this topic. Okay, with this, I'm going to give a break and Q should not be distributed. What is the meaning of Q? Load per unit area. Q means kilonewton per meter square, load per unit area. So whether you divide or extend, the Q value is not going to be changes. That is the pressure, Nana. Q value won't be changed. If I give you total load, kilonewtons, then it is going to be changes. But kilonewton per meter square. Over a meter square, what is the load acting over here? So you don't need to worry about that. Now, that's all. Okay, fine. So that's all about the conditions over here. Now it's 11:15. I'm giving you break of 20 minutes. So 11:35 up to 11:35, you have a break. Meanwhile, I gave you one question. So you please solve this question also. You please solve this question also. So let me know the answers. Okay, sorry for the late. Yes, sorry for the late. Okay, so now let's start the next one. See, whatever the answer for the so the answer for this question, answer is 15.63 kilonewton per meter square. So this is the answer. The people who have messaged me, I mean, some of the people have messaged me in the previous session itself. So the people who have done this one, the answer is going to 15.63 kilonewton per meter square. So you please go through that. Now, let's see the next question. Yes. So now the question is the next question. What is the next question? Yes. See this question number 6. See this question number 6. Yes. So if you observe the question number 6, the flexible area shown in the figure is uniformly loaded. So given that Q is equals to 200 kilonewton per meter square. So what is the Q over here? Uniformly distributed loaded. So the structure means whatever the pressure intensity is going to be 200 kilonewton per meter square. Determine the vertical stress at point C. See, this is the point C, and which is at a depth of 3 meters. Now, if you observe carefully, in this is a section or a loaded area which consists of a rectangle and a semicircle. You see, this is going to be a rectangle, and here it is going to be a semicircle. And if you observe, this point C exactly under the center line of the circle or not? This is a semicircle, and this is center line, and this point is exactly below the center line, which means I can use circular loaded area formula. And not only this one, for rectangle, you see, for M, N, I, they have given these values. So for M, N, I, they have given these values, means just now we discussed about Newmark's method. Newmark's method is suitable for whom? Rectangular loaded areas. So this question consists of both circular loaded area and rectangular loaded area. So now let's solve this question. With this question, we can understand the concept much more better. So let's see what are the dimensions: 3 meters, 8 meters, 1.5 and 3 meters. Next. Classroom practice question, question number 10. Question number 10, the classroom practice question. You see, so this is a rectangle. Yes. So this is the portion they have mentioned. Now, you observe in this question, I gave the dimensions. And in the case of section view, yes. So now, whatever the details I mentioned, this is 3 meters, and here this is going to be 8 meters, and this intensity of pressure, this pressure intensity is Q is equals to, what is the value of Q we have? The value of Q is 200 kilonewton per meter square. 200 kilonewton per meter square. So now The point C is located at this point, and it was mentioned the radius is equals to 1.5 meters. See, if this is a radius, what is the total here? And this is also going to be a radius, right? Which means this is also going to be 1.5. See, what is the total width of the rectangle here? 3 meters. And this is a r is equals to 1.5 meter. Then definitely this is a semicircle, and this point C is exactly at the center. And moreover that under the center line, yet Z is equals to 3 meters. What is the vertical stress? So now, first of all, as this is going to be rectangular loaded area, you know that according to the Newmark's method, the point that we need to consider should be always taken as a corner of the rectangle. Yes. So now this is the point where I want to consider. So which means what I am going to do is this is the point, right? This point should act as a corner of the rectangle. If you want to use M, N, I, definitely you have to go for the Newmark's method, and you need to divide this into equal rectangle. Now you see, and if you observe here, this is a one rectangle. This is one rectangle. So now I can say rectangle number 1, rectangle number 2, and semicircle is going to be 3. So this is going to be the semicircle. Okay, fine. This is going to be the semicircle. So now we need to find out the stresses. We need to find out the stress. See, due to one sigma 1, due to 2 sigma 2, due to 3 sigma 3. So you know that sigma z is equals to sigma 1 plus sigma 2 plus sigma 3. Whereas as the dimensions, what is the dimensions over here, please? What is this dimension? 1.5 meter, and this is 8 meters. This is 1.5 meters, and this is going to be 8 meters. See, for rectangles 1 and 2, dimensions are same. When the dimensions are same, I told you I1 is equals to I2, then sigma 1 is equals to sigma 2. So I can write here sigma z is equals to 2 times of sigma 1 plus sigma 3. What is sigma 1? I1 into Q. What is sigma 1? I1 into Q. So now this I1 depends upon M1 and N1. So what is M1 over here? L1 by Z. So what is 8 by 3? Similarly, N1 1.5 by Z. So B1 by Z. So 1.5 by 3, 8 by 3, 2.67, and N1 0.5. So now they have mentioned, now we have find out the M1 and N1. Now let's go to the question. In the given question, they mentioned the M value and the N value. See here, they take M as 0.5 and N as a 2.67. Whatever it may be, I told you clearly, you can take either M, means you can take the M either as a length or width. One should be length, other should be width. If M is length and N should be with respect to width. And if M is with respect to width, then N should be with respect to length. So now, if you observe in this, for these values of 0.5 and 2.67, what is I value we have? 0.1365. So now you fix this value 0.1365. from data, I1 is equals to 0.1365. 0.1365. So now sigma 3. Sigma 3 for circular loaded area, you know that Q into 1 minus 1 by 1 plus R by Z whole square whole to the power of 3 by 2. But you see, is it a circular, full circle or semicircle over here? Semicircle. This is a semicircle. See, whatever inside this is not there. Outside only there is semicircle. So this is a semicircle. So semicircle means exactly half. So full circle full. So semicircle means exactly half. I take half of this portion because half means exactly, means a full total, and semicircle half. Now we find out the value of sigma 3, please. Half into, what is the Q value? 200. See here, substitute please. 0.1365 into 200. So find out those values. And 1 by 2 into 200 into 1 minus 1 by 1 plus, what is the radius over here? 1.5 Z full to the power of 3 by 2. So after you calculate this one, 0.1365 into 200, which is going to be 27.3 kilopascals, and sigma 3 is going to be 1.5 by 3 whole square plus 1 by whole to the power of 3 by 2, 1 minus into 100. So sigma 3 is going to be 28.44 kilopascals. Then what is sigma Z? 2 times of 27.3 plus 28.44. So which is going to be 83.04 kilopascals. So the answer is going to be 83.04 kilopascals, Nana. In GATE, most of the questions have been asked in the rectangular loaded areas. And Bosnian theories. So these theories, everything has the same importance. You have to go through all these theories only, means how to apply this one. So now, today I am going to give you, why can't we take rectangle as a whole? Where you are full, tell me, why can't you take a rectangle as a whole? Where are you? Wherever I take the point, that point should be considered as a corner of rectangle, right? Why can't I take this entire as a whole rectangle? Tell me now. Why can't I take it? I took 40 minutes for explain this one and you are asking this question now. They have given the details of m comma n, right? When they give the m comma n, what is the meaning of details of m comma n? I, m, n represents whom? Newmark's method. Newmark's method represents whom? The point at which you need to find should be considered as corner. So this point needs to be corner. If I want to make sure this point has a corner, then I have to divide into two rectangles. Mr. Nikhil sir, can we use two different theories in same question? Yes, we can. Sir, why can't we take in the case of semicircle R as R by 2? Arey Baba, aapko dimag kaha hai bhai? R means radius re bhai. How come you take for semicircle? Okay, fine. If I say for full circle, radius is going to be 2 meters. For semicircle, it is going to be 1 meter. If I is not given, then how we can find out from m and n? My dear, here the I will be definitely mentioned in the examination. There is no point they cannot mention the I value. They will give you m, n corresponding I. You need to find out m and n. You look over the table and you find out the I value. And one more thing I want to say over here, tomorrow is a holiday. Sunday, tomorrow is a holiday. Why? Because we are going to end this chapter number 10 today. So there is one more method left over, new marks chart and approximate method. So those are small methods only. Now we'll be ending over those. You please listen to me once. Everybody have a, please listen to me. We have completed, means we are going to complete 10 chapters, and I am going to conduct a test for all the first 10 chapters. I'm going to conduct a test for all the 10 chapters. I'll give you some 15 questions. So the examination will be on Tuesday. The examination will be on Tuesday. So Tuesday, the timings will be let you know on Monday. I will be letting you know the timings on Monday, but the examination will be Tuesday, either on Tuesday after 2:30, means after the class, or at the evening in Tuesday. So on the Tuesday, there will be examination on the first 5 chapters. So you can go through your login ID details there, where I am going to provide your test series questions. So for 15 questions, and the next day, I am going to say who are going to the first 10 toppers in the examination in this classroom itself. So those who has been appeared so far, and some of the people I don't think they have been appeared. So please let them to know. If you know anyone, I will be attaching that PDF, and I am going to write that on the PDF also. So the people who have missed today's class, or if your friends are there, I am going to conduct test on first 10 chapters on Tuesday. Either it may be afternoon or evening. The exact timing will be let you know on Monday. So we are going to complete that chapter number 10 today, and tomorrow is a holiday. Actually, Monday is a holiday every day, but I don't want to start a new chapter tomorrow and then take a holiday. So have a holiday tomorrow, and you prepare for the first 10 chapters cleanly. I provided you a lot of resources. You have video, you have my PDF files. I gave you assignment problems. You have classroom practice questions. I gave you previous gate questions and previous ES questions. And after all those things, you covered almost all the topics. And I am going to give you questions based upon all those things. I hope you people will write, and you people will get a good score. If you don't write, then you are going to be the losers, not the others. If you write, whether you get a less marks also fine. You please give the test and make sure that you people are worth for that, and make sure I am worth for having a class with you. After all these discussions, what I required from all of you people is your understanding of the concepts, and I'll be getting to know how you people have understood these concepts from the test. So make sure yourself available for the test and prepare. Tomorrow, you please prepare the entire 10 chapters on today and tomorrow onwards, in tomorrow. So you, the whole day, there is no class for you. You please prepare for the first 10 chapters. That's it. For all the 10 chapters, no. From 1 to 10. No, not on 1 week. It's been 18 days we have been taken. This is the 19th day. So Tuesday, test would be on Tuesday. That's it. No, I won't give 5 chapters at a time. Instead of that, I'll give you more questions. Time duration. The time duration and how many number of questions I will be discussed, I will be let you know on Monday. The time duration will be let you know on Monday, but there will be definitely a test on Tuesday. Okay. So now let's come to the question. अरे बाबा टेस्ट विल बी इन एमसीक्यूज. अरे क्या रे भाई, In the case of GATE and EAC, both MCQs and GATE, especially numerical types would be there. Both would be there, and the test is for first chapter to 10 chapters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 chapters are there, not 1 to 5. 10 chapters are there. The test is fixed. So no matter what, I say I'm not going to lag it for 1 week. I just said you now because of I will see how you people have done work in all the days. Whatever the PDFs I have provided, I will get to know how many of you people have actually done the assignments. Assignment solutions I will be sending today. Okay, fine. Now let's not waste our time. So now today I'm giving you, see, I explained you question number 6. Now you see the question number 4, please. You see the question number 4. The vertical stress at some depth below the corner of a 1 meter by 1.5 meter rectangle footing due to certain load intensity is 100 kilonewton per meter square. What is the meaning of this one? The vertical stress at some depth. The vertical stress at some depth below the corner of a 1 meter by 1.5 meter. See, there is a vertical stress at some depth below corner of a, this is a rectangle, and at this corner below some depth there is a vertical stress, and that vertical stress is 100 kilonewton per meter square. At certain load intensity, let's take the load intensity as Q, and they have given sigma z as 100. What will be the vertical stress in kilonewton per meter square below the center of a 2 meter by 3 meter rectangular footing at the same depth and same load intensity? So now you see, classroom practice question number 4. At first, see, this is one rectangle of dimensions 1.5 meter by 1 meter. Due to certain load intensity at some depth on its corner, the sigma z at a particular depth, the sigma z is given as 100 kilopascals. At a particular depth z, the sigma z is given as 100 kilopascals. And now there is a one more rectangle. Now these dimensions are going to be, these dimensions are 3 meters and 2 meters. So now if I apply the same Q value, what would be the stress at the center? What would be the stress at the center? And the depth is going to be same. The depth is going to be same depth, Nana. So whatever this depth is going to be same depth below this at a particular depth, right? So what they asked is, if I apply same loading intensity over 3 meter by 2 meter rectangle at the same depth, what is the vertical stress? So now, as it is a center, can I divide the center into 4 parts so that this center point will act as a corner for everything? So now what I do is I simply divide this into 4 parts. If I divide this into 4 parts, now if I divide it into 4 parts, now let's take only one rectangle. So can you please tell me what is the dimension of this one rectangle over here? So what is the dimensions of one rectangle over here? The one rectangle dimension is going to be 1 meter by 1.5 meter. And now this point is going to act like a corner. Now you see, just this is going to be a replica of this one or not? So this is cube, okay. This is dimensions 1.5 by 1 meter, and the stress is going to be how much? 100. Likewise, how many rectangles are there? 1, 2, 3, 4. So if we divide rectangle into 4 parts, each part resembles earlier condition. Means earlier condition means this one. So with this I can write, you see, sigma z is equals to, see, for one rectangle what is the stress? 100. How many rectangles are there? 4. 4 into 100, which is going to be 400 kilopascal. Okay, that's about the classroom practice question. Now, so apart from this, we have solved question number 2 and question number 3. Now, with this, see, I am giving you question number 1 as homework. You please everybody have a look. This question number 1, there is a rectangular loaded area UDL of 8 ton per meter square at ground surface. Find the vertical stress at 5 meters below the center and corner. You see they have given the I think a small error has been here. I will write these values, so you please take a screenshot over here. So the values would be M L by Z, N B by Z, and I value. So if M is equals to 0.4, N is equals to 0.2, I value 0.0328. I value 0.0328. And similarly, M is equals to 0.8 and N is equals to 0.4. Yes. Then I value is going to be 0.0931. So this is the data. This is the actual data. So you please take this data, and they have given the dimensions, right? Already they mentioned the dimensions, so you don't need to worry about the dimensions. You please take this as a screenshot, or else I will save this one. So don't worry. I'll share this one. You see, this is a homework for you. This is a homework for you. So question number 1 is a homework for you. If you want, you can take the screenshot also. UDL acting on the ground surface. What is the meaning of UDL acting on the ground surface? Whatever the loads I have taken so far, that has been acted on the ground surface only. Okay, fine. Let's discuss the remaining things. So I hope you have saved this one, and I saved already. So now, next question number 5 is also homework for you. Question number 5 is also a homework for you. So in this chapter, total 7 questions are there. So we have done question number 2, means I have given you question number 2, question number 3, question number 4, and question number 6. So now I gave you the homework as question number 1 and question number 5 as a homework for you. Solve. Solve question number, see, classroom practice questions, question number 1 and 5. This is a homework for you. Now, next up, Newmark's chart. Newmark's chart, and again this Newmark's chart is based on Bosnisk's. This Newmark's chart is also based on Bosnisk's. So this Newmark's chart can be used for any irregular or regular loaded area. For any irregular or regular loaded area. Sir, why you are writing a irregular or regular loaded area, sir? See, this Bosnisk, not only he gave an point load, but also line load, but also circular load, and then he got to know that, array, in reality, the load can be any type, right? It can be circle, it can be rectangle, it can be square, it can be L shape, it can be some irregular shape also. Then how to solve this one? This is based upon the Newmark's chart. So first, let's see what is the condition of this Newmark's chart. This Newmark's chart is based upon the Bosnisk only, and for any irregular or regular loaded area. This Newmark's method is completely for the rectangular loaded area only. Newmark's method is completely for rectangular loaded area. Now let's see this condition over here. What is this condition represents? First of all, this Newmark's chart. First, let's go with the Newmark's chart, and then so let's talk the Newmark's chart first, and then we'll see how this is going to be suitable to determine stress for any irregular loaded area. See, now this Newmark's chart consists of a concentric circles. What is the meaning of concentric circles, sir? The concentric circles meaning is they have a common center. They have a common center. So now this is one circle. Likewise, see, this is one more circle, and you see both are concentric. What is the meaning of concentric? The meaning of concentric are both are going to be having a same center. Both are going to be having same center. So now okay, again, now if you observe what I am going to draw you here, you please observe, do you think, see, this is also a circle, but what about the space over here? You see, observe, here this is the space and here this is the space. See, as the circular radius is going to be increases, the space between one circle to other circle also increases. Observe carefully once again. See, this is the space between one circle to other circle. Now this is going to be the space, and this space is known as the annular space, means space. annular space. So as the circle is going to be increases, as the circles are going to be increases, the space between one circle to other circle also increases. Similarly, see likewise, there are n number of circles. So totally, if you observe clearly, these circles are going to be concentric. The meaning of concentric is every circle has a same center. So likewise, you see, yes. So the total number of circles are in a given Newmark's chart generally the total number of circles is equals to, there are 10 circles. Generally, for a given Newmark's chart, total number of circles are going to be 10 circles. I am not drawing all those 10 circles. Now, these 10 circles are going to be divided into sectors by drawing a radial lines. See just now how you cut down the pizza into slices. Just how you are going to cut down the pizza into slices. So let's say, okay, fine. Let's say this is a pizza. Let's say this is a pizza. So now how you are going to cut down? See, what you do is from the center, you draw one line over here, means by taking one cut, and you see here, this is one slice, yes or no? So likewise, yes. So here, how many slices are there? This is a pizza. Let's take how many slices are there? 1, 2, 3, 4, 5 slices are there. Which means for one pizza, how many lines I have drawn? I have drawn 1, 2, 3, 4, 5. So when I draw 5 radial lines, means if I cut down the pizza into 5 different times, I can make into 5 slices or not, which means you please observe over here. This is a pizza which is circle, and these are the slices, which means sectors, And how you have made this pizza into 5 sectors, means 5 slices, by cutting down into 5 times, means 5 different directions. Yes or no? I can call them as a radial lines. So similarly, now what I am going to do is I am going to divide these circles into the sectors by drawing the radial lines. So if you observe here, let's draw. This is C. With respect to center, how many slices I have done? Now you observe very carefully. You take one circle at a time. How many slices are there? 1, 2. So for a given circle, one circle, if I draw 2 radial lines, how many sectors are there? 2 sectors are there. Similarly, this is sector, means radial line 3. This is going to be radial line 4. So now how many radial lines are there? Whatever the green represents are radial lines over here. How many radial lines are there? 4 radial lines are there. Then how many sectors are there? 1, 2, 3, 4. So 4 sectors. Are one circle, 4 radial lines. How many sectors are there? 4. And likewise 5, 6, 7, 8, 9, 10, 11, 12. Likewise, How many circles are there? 10 circles are there. 10 circles, and for each and every circle, I am dividing into 4 radial lines, which means 4 sectors. One circle, 4 sectors. Then total 10 circles, how many sectors? 10 into 40 sectors. So likewise, we are going to divide this into n number of sectors. So likewise, I am going to divide into some 20 sectors. I'm going to divide into some 20 sectors. So generally, the total number of radial lines are, so 20 radial lines. What are these? These are radial lines. So for a given Newmark chart, generally the total number of circles are 10 and total number of radial lines are 20. Then total number of sectors is equals to 10 circles into 20 radial lines, which is going to be 200. Now for every Newmark chart, there is a one value known as I value 0.005 and line depth as 5 centimeters. See, for every Newmark chart, this is a Newmark chart I have provided or not. For every Newmark chart, this is a chart, and in this chart, likewise, see, 10 circles would be there in this chart, and I'm going to divide into some n number of radial lines. I did not draw the 20 radial lines over here, but I'm just drawing you generally the total number of circles are 10 and total number of radial lines are 20, and each one has some I value and line depth. Now, what is this I value, sir? See, in the case of the Newmark's method, I took the I value. There I said influence factor. Now, here also I'm going to take the I values. Then what is this I value, sir? This I value is going to be where I value is equals to influence. Now it is going to be influence coefficient. Influence coefficient. So that I is equals to 1 by number of sectors. 1 by number of sectors. So I is equals to 1 by total number. How many number of sectors are there? 200. So then what is the 1 by 200? Please tell me. 1 by 200 means 0.005 or not. So 1 by 200, which is going to be 0.005. Now you see, for a given chart, I is going to be 0.005. How we got this I value, sir? That I value is nothing but 1 by number of sectors, sir, which means for a given chart, I is constant because I value depends upon the number of sectors. So what about this line depth, sir? Wait for that. I'll be discussing that line depth later. So as of now, for the given chart, what is I value? 0.005. So now, see, sir, you have run only 5 circles, sir, Baba. I have run 5 circles, but generally there are 10 circles. I cannot draw all the 10 circles over here. Okay, fine. So now, what to do? So what is the significance over here? Significance of chart. The significance of the chart is, you take any sector, whether the sector is going to be very near to you whether the sector is going to be far away from you. This is sector number 1, and here this is a sector. This is sector number 2. So this is sector number 1. Here this is sector number 1. So whatever the sector, whether the sector is far away from the center or whether the sector is near to the center. This was one of the previous IS question also. So in the given figure, every sector has same stress at center. This is the significance of this. Every sector has same stress at the center. This is the significance. So from chart shown, you see here, whatever this one, sector 1 and sector 2. Sector 1 and sector 2 has same stress at center. So this is the significance of the chart. So they will give you two sectors, whether the sector is away or near. Whether the sector is away or near, it doesn't matter. Every sector has the same stress at the center. So now you see over here. Let's take an irregular loaded area. Example. Irregular loaded area, because we need to find out stress for whom? Irregular loaded area. So now let's come to the, for any irregular or loaded area, how to determine the stresses. So let's take some L shape rectangle loaded area. See, so this is some L shape or rectangular loaded area. Now, if you observe in the plan view, this is a rectangular loaded area, means a L shaped loaded area, and in the section view, this is in the section view. Here it is a section, which means ground level. On ground level, we just see this one as some strip which is having some stress as Q. So now my question is, see, can I use a Bosnian theory over here, means point load theory? No. Can we consider it as circular loaded area? No. Can we consider it as lower line load? No. Can we take it as a rectangle? No. So for example, if I want to consider this one, I want to find out the stress at this corner A. See, this is some regular loaded area. I can use some hexagon, or I can give you some any other value also. Now, how to determine this one here? As observe, I want stress at this point at a depth Z. What is the vertical stress over here? So for that, what I'm going to use is I'm going to use the Newmark's chart. So how you are going to use the Newmark's chart, sir? This Newmark's chart is going to be used to determine the vertical stress for any irregular loaded area. But this is in the laboratory. Yes, this is a chart. This is a chart. And what about this one? This is in the field. So On there is a chart and there is a field. One thing, whatever it is going to be field, chart is in the laboratory and the loaded area is in the field. So in order to apply the Newmark's chart to this chart, what we going to do is we transfer this one into a transparent sheet. We transfer this one into a transparent sheet. See, what is this sheet, sir? The sheet name is transparent sheet. I hope you can see this transparent sheet generally. So this transparent sheet, it can be available everywhere in the, whatever the bookstores, transparent sheet would be there. So then what we are going to do is we'll just simply scale this. We just simply scale this. Yes. So now what I do is I just simply scale it by scaling. Sir, what is the scaling that you are going to do here, sir? This is a transparent sheet. I am going to change this one into over here. And this is the point where I want to find out the E, where I want to find out the stress. So now what we are going to do here is we convert this loaded area, or we transfer the loaded area over a transparent sheet by scaling. What is the scale, sir? Now let's say, for example, over here, I want to find out example for scaling, line depth of chart should equals to depth at which stress to be calculated. Depth at which stress to be calculated. So for scaling, line depth of the chart should equals to depth at which stress to be calculated. For example, let's take I want to find out the stress at 10 meters. I want to find out the stress at 10 meters. So now for this 10 meters, what I am going to do is what is the line depth given? The line depth is going to be how much here? 5 centimeters. So line depth should be equals to Z. What is the line depth? 5 centimeters is equals to 10 meters. And 1 centimeter is equals to 2 meters. Or I can write 1 centimeter is equals to 200 centimeters. Now the scale is equals to 1:200. So what is the meaning of this one? The meaning of this one is 1 centimeter on transparent sheet is 2 meters of load from field. See, for example, if I take this is going to be 2 meters over here, then what is this value? 1 centimeter. Understood or not? So if I take this is 2 meters, then the scale is going to be for every 1 centimeter on the transparent sheet, then 2 meters of the field. If it is 2 meters, then it's 1 centimeter. And if this length is going to be 8 meters, then this one should be 4 centimeters. I hope you understood the meaning behind it. So if I say this is going to be 8 meters, this is going to be 4 centimeters. From the example, I can take this scale. This is an example purpose only. This is an example purpose only, not the real values. So the scale is going to be 1:200. Now once the scale is going to be present, place transparent sheet over Newmark's chart so as point A should coincide with Newmark's chart. Point A should coincide with the center of chart. See, now what I do is I take the transparent sheet and I place the sheet over the Newmark's chart. So as whatever the point A means, the point where I want to find out the stress should coincide with the center of the chart. So now what I do is let's go to the Newmark's chart. And this is a transparent sheet already we have. Now place this transparent sheet over the chart so as the point where you need to find out that should coincide with the center. So now let's draw that. So now you observe exactly how I have placed over here. How I have placed, I place the sheet wherever the point I need to find out A should exactly coincide with the center. Should exactly coincide with the center. So now this point A, this is A. So now after placing this one, what we are going to do, sir, is note down the number of sectors covered by the loaded area. Note down the number of sectors covered by the loaded area. So this is the number of sectors we are going to cover by the loaded area. So whatever the number of sectors are that is going to be covered by the loaded area, we are going to find it on. Now you please observe here carefully. Everybody, I hope. See, this is one sector, 2, 3, 4, and this is a full. This is a 5. But now from now onwards, if you observe over here, see, this is a full sector. But in this, the portion is going to be filled only certain percentage. Yes or no? And here also, this is not a full sector. And here also, it is not a full sector. There comes the ambiguity and difficulty in this chart. So far and so good, there is no difficulty. But the difficulty is while you are noting down the number of sectors, you have to take the exact portion. For example, if this sector is going to be covered by 30%, then you have to take that number as 0.3 only. You cannot take it as full one. So for finding how much sector is going to be covered, we use some surveying techniques. We use some surveying techniques. We use some surveying techniques. I hope you remember area volume technique in your BTech. So in order to find out how much area of this sector is going to be covered, you need to use area volume technique that you don't need to worry about for the GATE examination. This method is completely a graphical procedure. So in the examination, they won't ask you how many number of sectors covered by giving this figure. They will give you the number of sectors. So don't worry about that. Now what you need to do here is, if you know the number of sectors covered by the loaded area, now the last point is note down the number of sectors covered by loaded area as N. Note down the number of sectors covered by loaded area as N. Then how to determine the sigma Z is equals to I into N into Q. So this is the equation provided here, I into N into Q. See, these questions in this topic are mostly they'll ask regarding to the IS pattern, because this is more of theory rather than the numericals. So in the ESC, they will give you more questions. So they will ask you, they will give you a number of circles, they will give you a number of radial lines. They can ask you what is the influence factor. Now you see this I for a given chart. For a given chart, the I is going to be fixed. And this Q for a given loaded area, Q is going to be fixed. Then this sigma Z entirely depends upon whom? Sigma Z is depends upon the number of sectors. So So as a depth increases, what happens over here? You please tell me. As a you please look over here. It's all depends upon the number of sectors. If you don't draw the figure clearly, then if you forget about how to measure the number of sectors, if you don't measure the number of sectors clearly, and if you do any mistake while counting the number of sectors, then the stress is going to be changes. See, this is a highly difficult method and it required a skilled labor, because any point you miss over here, then it will be ending with a different Z value. So in GATE examination, they won't give you this figure and they won't ask you number of sectors. They will directly give you the number of sectors. Yes, you can use the planimeter. So whole circle bearing in surveying, there are a lot of techniques. You can use those. Yes. So now that's about this method. This is a Newmark's chart. So what we have done is simply we have taken this one and we applied over here and we write down the number of sectors and find out the sigma z as I into n into q. Now the next method is approximation method. How this method is useful? Arey Baba, kahre bhai aapko? Kyare bhai, irregular or regular loaded areas. You can use this one for any loaded areas. Now, approximation method. What is this approximation method? Is 2 vertical to 1 horizontal dispersion. See, this does not have any formulas or something else. You please look over how it is going to be. How? Look, if this is a footing, constructed below the ground level. If this is a footing constructed below the ground level, whatever this is nothing but the ground level, and you know whatever the load, this is going to be Q, and now you know the base width as a B. So what happens over here, sir? Here you observe the load is going to be transferred through whom? The load is going to be transferred through the base. Let's take D is the depth of foundation. Let's take D is the depth of foundation. In the case of approximation method, this load will transfer through the base of footing, and whatever the intensity of this pressure Q, this Q is equals to capital Q by area of footing. Okay. So now how to determine the stress? Sir, whatever the stress at the base of the footing is nothing but the Q, sir. Small q is equals to capital Q by area of footing. Now, how this stress is going to be developed? See, I want to find out a stress on a plane at a depth Z. I want to find out a stress on a plane at a depth Z. So now let's see. This is a plane on which I want to find out the sigma Z. So let's say whatever this depth is going to be, Z, because whatever the Z I am taking is below the load only. This is the pressure that is going to be transferred. So now, according to approximation method, what it says is whatever the load passing through the base of footing is going to be dispersed into soil with a dispersion angle of 2 vertical to 1 horizontal. which means while it is dispersing, you observe over here, while it is dispersing, what is going to be happen over here is what is going to be happen over here is the load will disperse with some angle. The load will disperse with some angle. So what is this angle, sir? See, you observe here. What is the stress? Stress means load by area. Yes or no? Load by area. Here the load is going to be same, but while it is going to be happen, this load will disperse as 2 vertical to 1 horizontal. If that is the case, two vertical to 1 horizontal. If that is the case, now, yeah, you observe over here. See, this is a B and this is also going to be B. Yes, here to here, this is going to be B. Now, what is going to be happen over here is so due to this load dispersion, the simply is when a load is going to be passing through the footing, through that footing, once it enters into the soil, the load will disperse. Now, 2 vertical to 1 horizontal. What is this vertical over here? Z. Then 2 vertical to 1 horizontal means can I write 1 vertical to 0.5 horizontal? 2 vertical to 1 horizontal. This is also going to be 2 vertical to 1 horizontal only. 2 vertical to 1 horizontal. Then can I write this 2 vertical to 1 horizontal as 1 vertical to 0.5 horizontal? Then I can write Z vertical to 0.5 Z. And here, what about here value? 0.5 Z. So now, can you please tell me what is the total width at this condition? What is the total width at this condition? The total width at this condition, the total width is equals to B plus Z. See, what is the width over here? B. And what is the total width over here? B plus Z. So now, what happens, sir? What is meant by stresses are load by area, sir. Load by area. So the stress means load by area. See, not only in this direction, in the all the other directions also, the load distribution is going to be happen in the same way. So now let me represent you in the plan view over here. In the plan view, this is a plan view, no? So in the case of the plan view, if this is a B width and this is going to be the length. So below the footing in the plan view, this load is going to be dispersed and whatever the width at the end is going to be B plus Z. So similarly, the load will disperse in all the directions. The load will disperse in all the directions as you see. The load will disperse in all the directions. See, I have shown you yes. I have shown you this front view. Okay. The front view means only the section view I have shown you. So now, if this is a B in the plan view, you can observe in the plan view, then what about this value? This value is going to be B plus Z and this value is going to be B plus Z and this value is going to be L plus Z and this value is going to be L plus Z. So due to this 2 vertical to 1 horizontal distribution, the values are going to be L plus Z, B plus Z. So now what is the area? The area is going to be at particular section. See, initially the area is going to be area of footing, where area of footing is going to be, if it is a square, B square. So now, how to determine these values, sir? So now, how to determine this as sigma z, sir? See, this is a sigma z, right? I want to find out the sigma z. So what about the sigma z? The sigma z is equals to load. What is the load? Column load. This is the column load by modified area. What is the modified area? Now you tell me, what is this area over here? See, I am writing you just a stress is nothing but load by area. Load is going to be same, but what happens to area? Earlier the area is going to be B by L. Now what is the area? B plus Z into L plus Z. So now in simple words, I can write, Are Baba, wherever the depth you want to find out. For example, you want to find it at 2 meters depth. Then you simply added that P plus 2. Then you simply add it as a B plus 2. Now by B plus Z whole square, if it is a square footing. If the footing is a square, then you can go for the B plus Z square, because if it is a square BB, then B plus Z and B plus Z. And now sigma Z is equals to Q by B plus Z into L plus Z if it is a rectangle, and sigma Z is equals to Q by pi by 4 into B plus Z whole square if it is a circle. So in simple words, there is no formula something or over here. You know that this Q is nothing but Q by B square if it is a square. So now what I do is simply, see, this is for square, right? And simply this Q, and now sigma Z is going to be Q by whatever B plus Z. So why it is going to be B plus Z, sir? Because the load dispersion angle is given as 2 vertical to 1 horizontal, sir. Then it is going to be B plus Z. So that's all with the approximation method. And one more formula. With that, we can complete this chapter. Please go through that once again. Array, why it is 0.5 Z? Array Baba, if this is Z, then what about this value? Just dispersion rate, 2 vertical, this is 1 horizontal. So if this is 2 vertical, Z is 2 times, then 1 horizontal means half times. Yes. So time up, please wait for 5 minutes. Within 5 minutes, I can conclude that. So that's it about the approximation method. What you need to know at the end is, you just add this depth to the width, then sigma Z is equals to Q by B plus Z whole square. Now the last one. Strip loading. Strip loading or strip footing. Can we get nearby answers if we use approximate method? Yes, we can get it. Now, please go over this question. Yes, again, yeah. If this is the ground level, if this is a ground level, and again, you can find out the sigma Z at center line of strip load or footing. Strip load or footing. So now let me take this is a strip. Let me take this is a strip whose intensity is going to be Q. So in terms of kilonewton per meter square only, strip per. See, actually this is per meter square means per meter. See, where do you see this strip is example retaining walls. Whatever the footing we use for the retaining walls, there is nothing but the strip footing. I hope you remember this is a retaining wall. So if this is a retaining wall, then along the length, then there must be the footing or not. So whatever this footing is nothing but the strip footing. So if it is a retaining wall, then how to find out this is a retaining wall, Nana? So now, how to find out the stress over here is, again, you have to find out the stress under the center line only. Under the center line only. If, let's say, B is width of footing, load or footing. So if B is width of footing, then you observe here, then this is going to be B by 2 and this is going to be Z. Then what is the vertical stress over here? Sigma Z. So just like a circular loaded area, here you have to find out at the center. Let's take the angle made by over here as a theta. So now how to find out this theta here? Tan theta is equals to B by 2 by Z. I can write this theta as a tan inverse of B by 2Z. So once you know this tan theta, then sigma Z is going to be found as Q by pi into 2 theta plus sine 2 theta. So then Q by pi into sine theta. So 2 theta plus sine 2 theta, where this theta should be in terms of radians and here it should be in terms of degrees, because you know that clearly when you allow or when you are using some angle with a single means without using sine or cos, then you have to represent in terms of radians. Radians means into pi by 180 degrees, and if you are using with respect to sine, you have to use it as a degrees. So this is the equation. For the strip loading, if the point is going to be exactly under the center. See, there is a one more equation. If the point is away from the center, but that is too complexity, you don't need to worry about that. See, in the case of the examination, if they mention strip loading, they will ask you what is the vertical stress at a center line depth of 10 meters. They can ask you this one. First of all, you need to find out the theta. What is the theta here? Tan inverse of B by 2 by Z. And then once you know this theta, then you can find out sigma Z is equals to Q by pi into 2 theta plus sine 2 theta. So that's all about the strip loading also. Now with this, we have completed all the topics. And now you see the classroom practice question. There is a one classroom practice question over here. This question number 7, you please observe. Question number 7. A strip of 3 meter wide, so width is going to be 3 meters, is located on the ground surface with a pressure of Q 100 kN per meter square. The average increase in the vertical stress at 10 meters depth. So 10 meters under the center line of the footing. You see, observe here, the footing is a strip footing. The footing is a strip footing, and where they're asking under the center line of the footing. So they given B is equals to 3 meters, Q is equals to 100, Z is equals to 10 meters. How to find out the stress? How to find out the stress? So, classroom practice question from the classroom practice question. Question number question number 7. Question number 7. So it is going to be strip footing. The width is given as 3 meters and load per unit area 100 kilopascals, and jet they have given as 10 meters. Yes, jet they have given as 10 meters. So now, as it is going to be load under center line, just now I mentioned you the sigma z is equals to q by pi into 2 theta plus sine 2 theta. First you find out the theta value. What is theta value? Tan inverse of b by 2 by z, which is nothing but tan inverse of b by 2 means 1.5 by z. So find out this value. Which is going to be 8.53 degrees. And if you want to convert in terms of radians into pi by 180, which is going to be 0.149 radians. 0.149 radians. Now the sigma z is equals to q 100 by pi into 2 into radians 0.149 plus sine 2 into 8.53 degrees. So now 2 plus sine 2 into 8.53 into 100 by pi. The answer is going to be 18.82 kilopascals. The answer is going to be 18.82 kilopascals. So I have given the values over there. Yes, 18.8 rounded to 1 decimal, 18.8, 2 decimals, 18.82. So with this, we have completed this chapter also. We have completed the chapter also. And there is a one topic, contact pressure distribution would be there, that we will be discussing in the next chapter, consolidation. So there is a one topic in the material, whatever the material they have provided you. So if you can see, means in the previous gate also, if you can observe, I'm telling you in the previous gate, you can see some questions. I'll be showing you this one. So everybody please listen. This is okay, fine. In previous gate, wherever you see the contact pressure distribution, you please okay, observe. You see in the previous gate, you can see this question. This question is this question we will be discussing consolidation chapter. We will be discussing consolidation chapter. So don't worry about that. Don't think that sir has not completed this one. So don't worry about that. This discussion, this I will be discussing in the consolidation chapter. So in this chapter, there are leftover gate and IES questions are there. You please go through those questions. I will be solving those later. So in this chapter, we completed all the things except the previous gate and IES. But you please go through that previous gate and IES. We'll be discussing in the next class. So it's already 1:10. So with this, I am ending the session, and with this, chapter number 10 is completed. So where are it footy? Where I have written footy there? Baba, that's not a footy. That's not footy or footing. Footy, I mean fruity. That's a footing. Load or fruiting. Sorry. Load or footing. Okay, that's with this I am going to stop the session now. Yes, one more point I just missed over here. One point I want to add over here. You observe. See, this Newmark's chart is based on the Bosnisk, right? And there is one more chart, Fensky chart, that is based upon the Westergaard's, but we don't use any Fensky chart. So I am writing one more point over here. Fensky chart is based on Westergaard's. So not used much. This is not going to be used much, but I have given you just there is a one more chart known as Fensky chart, but we don't use the Fensky chart much, so don't worry about that Fensky chart and all those things. So with this, I completed today's session, and now those who wants to leave, they can leave. And tomorrow there is no class, and examination would be on Tuesday for the first 1 to 10 chapters. Those who wants to leave, they can leave. Now I'll take the doubt clearing sessions for the people. I'll be taking the doubt clearing session now. So I'm enabling the raise hand option. So I just enabled the raise hand option, and meanwhile, sir, please keep your preparation schedule. No, I won't. You please prepare yourself. Sir, and is appropriate method applicable for both regular and irregular areas? No, it is applicable only for the regular areas. See, this is the footings. This approximation method is for the footings, Nana. What is Newmark's method? Newmark's method I have been already discussed. Can we solve the question with approximate method, though it is asked to solve it by strip method? No. If they ask a strip method, you have to apply strip only, not approximation method. Yes, less conceptual, more mugging work in this chapter. Yes, that's true. So because if you want to go for the conceptual is going to be derivations over here. You don't need to worry about the derivation here. There are a lot of techniques. You have to go through this one. You need to know how to apply this one. Mr. Harish, so please explain question number 5 in chapter number. Question number 5. What's the Mr. Harish? This question, you please go through that, Nana. Find the depth under the axis of a load where the stress induced is 10% of the applied stress. See, Q is applied stress. Yes. And they have given the circular footing, right? Q is the applied stress. Now, you need to find out where, whenever there is a 10%, then sigma z is going to be 0.1 Q. You know the equation, Q into 1 minus 1 by 1 plus R by Z whole square whole to the power of 3 by 2. Yes, this equation you know. See, they mentioned the, yes, they mentioned 10% of the applied stress means sigma Z is 0.1 Q. So then 0.1 Q is equals to this value, Q will get cancelled, and they have given the dia means 4 meters, then R is equals to 2 meters. They're asking about the depth. So find out the depth. You please equate this circular footing, and this 10% is going to be 0.1 Q, which means sigma Z is going to be 0.1 Q. I hope you understood that. Will there be class on Monday? Yes, there will be class on Monday. Is Fensky chart study is necessary? No, it's not necessary. Try to post video fast as possible. So I told you the problem with the video, so it will be happen. It will take time. So see, sir, upload your prepared short notes. I hope I have sent that, but I'll just check. Okay. Now let's start our people who are waiting, waiting. My dear Vinay, please unmute yourself.
Good afternoon, sir.
Good afternoon, Vinay.
I have a doubt regarding 9th chapter, 6th question, sir.
9th chapter.
CPG analysis. CPG analysis.
Means 1 minute. Okay, let me see. Which one you are asking?
CRPQ.
PL?
CRPQ, sir.
Yeah. Okay.
Exit gradient question, sir.
9th chapter. Which question?
6th question, sir.
5th question.
6th, sir.
Yes, this question. Yes. Okay. Fine. Tell me what happened over there.
Sir, their options are correct. Answer is correct, or is there any mistake in it? In this, sir?
Answer is correct. What is the answer you got?
I got 2.54, sir. 554.
No, it's 3.4. It's
Can you
3.4.
explain shortly?
What is the fine? You please tell me what is the delta H over here? How many number of drops are here?
Number of drops 6, sir.
6 are. Look closely. How many number of drops are there?
Oh, okay, sir. 7, sir.
7. What is this? 1, 2, 3, 4, 5, 6, 7. How many number of drops are there? Tell me.
7, sir. 7.
Here itself we have done it wrong. Here ND is 8. See, you just see the figure. You please represent the numbers, Nana. You please represent the numbers, then you will get it right.
It will be much easier, sir.
Yeah. So there you have done the mistake. So if you do it, then you can get the answers. Okay, fine.
Okay, sir.
Yes. Sir. Okay, fine.
Thank you, sir.
Mr. Chinnu. Mr. Chinnu.
Sir, good afternoon, sir.
Good afternoon, Chinnu.
Sir, I had a doubt regarding CRPQ 3, sir.
CRPQ?
3.
Which chapter?
10th chapter, sir.
10th chapter. Just
That
now.
circular one. Yeah, yes, sir.
Tell me.
Sir, here we considered to find sigma z, we done sigma z outer minus sigma z inner, na, sir?
Yes.
Sir, can't we do in a single step by substituting r value as outer minus inner, like 4 minus 3 in place of r?
No, you cannot, because the stress depends upon the radius and the depth also. Okay.
Okay, sir.
So you cannot directly take it as average.
Okay, sir.
Yeah.
Sir, one more thing, sir.
Yes.
Sir, in the preventive measures of piping failure,
Okay.
in the third condition, we taken it as by providing inverted filter.
Yes.
Sir, will we do it practically?
Yes, we do it practically. We do practically. While we are constructing the dam, right?
Sir.
While you are constructing the dam foundation, on its upstream and downstream, we need to provide air filters. In irrigation, there is one chapter known as a hydraulic chapter is there. There you
okay, sir.
Launching apron, block protection, inverted filter, sheet pile walls, everything you have to complete, because when you are constructing a hydraulic structure, if you are constructing a dam, you are not going to construct only dam. You have to save the dam and the soil mass. So,
sir, by
that inverted filter.
Sir, there we are allowing water to downstream side, na, sir?
Yes.
Whether the water quantity is less or more, sir?
See, it depends upon the permeability of soil, right?
Okay, like my doubt is, if we allow water through that, without, we'll be doing it without any intimation to the low-lying areas, na, sir? Near to the dam.
Don't think, see, I'm telling you, don't think that is going to be comes as a meters by meters. It is not going to be flow of a meters by meters. You please go through the previous questions and whatever the chapter number 6 we discussed about the discharge, right? Q Kia.
Yeah.
You
Yes,
please
sir.
put the numericals. What is the value of numericals? You can observe how much value is very less. In soil, the amount of water passing is very less. Okay, but
Okay, sir.
soil has an ability to allow water, so it is allowing. When it is allowing, as an engineer, we have to allow the water from the soil to outside, so that soil would be safe.
Okay, sir.
Soil does not know how to safeguard itself. Okay,
Hmm.
engineers, we need to know how to safeguard the soil. Fine.
Sir, one more, sir.
Yeah.
Sir, once can you open the slide regarding Newmark's chart, sir? Which you had taken example, irregular.
Yes. Tell me.
Sir, we can, like, my idea is like, we can calculate the sigma z of this particular diagram through rectangular, like,
Yes,
we
for this one you
discussed
can
it
find out. For this one you can find out. If I give you something like this, can you find it out?
sir.
For this is a one shape. Then you can find out. Okay.
Yeah, yes, sir.
But if I take this is one shape, then can you find out this one? This is
No,
also
sir.
area.
I am not obsessing. I am not against you, sir. I'm just
Yeah.
asking whether we can do or not, like that.
I mean, I understand. Yes, you can find out the same thing by using the rectangular loaded area, but
Yeah, yes, sir.
divide it into parts.
Okay, sir.
Yeah. Okay.
Thank you, sir.
Yes. Next, Miss Nikita. Miss Nikita, please speak out. Miss Sai Nikita, please speak out. Hello. Miss Sai Nikita. Okay, fine. Next, Aditya. Aditya.
Hello,
Yeah, yes, Aditya.
sir. I have doubt in previous IES question, sir. Chapter 8,
Chapter 8.
14 questions.
Question.
Yes, sir.
The possibility of piping in failure means of piping failure in earth dams is more if black cotton soil is the foundation material. And the highly expansive black cotton soil are the most common soils wherever basalt rock is present. See, the possibility of piping failure in earth dams is more if black cotton soil is the foundation material. No, because in the case of the clay soil mass, black cotton soil is a clay, right?
Yes, sir.
In the case of the clay soil mass, due to cohesion between the particles, the clay particles won't erode that much.
Okay, sir. Sir, I have doubt in the reason, sir.
Yeah, the reason is the highly expansive black cotton soil. See, whatever the black cotton soil is a chemically weathered deposit, right?
Yes, sir.
So the parent rock of the chemically weathered deposit of black cotton soil is basalt. Basalt is a parent rock.
Okay, sir.
So from that only this black cotton soil has been arrived. So assertion is true and reason is true, but they are not correct.
Not related, no, sir.
Not real, not related.
Sir, 18, sir, in the same chapter.
The possibility of quicksand condition occurring is more on the downstream of a weir on a permeable foundation than on the upstream end with an upward component of seepage velocity. The possibility of quicksand condition occurring is more on the downstream of a weir on a permeable foundation than on the upstream end with an upward component of a seepage velocity. So where do we see the seepage quicksand condition? Do we see the quicksand condition on downstream side or upstream side? Downstream.
In the downstream side.
So definitely on the downstream side is going to be more.
Yes,
Next.
sir.
Seepage lines end with an upward component of seepage velocity at the downstream reaches of seepage lines ends with an upward component of seepage velocity at the downstream reaches of such a weir. Yes. So on the downstream side, the seepage is going to be upward seepage or not?
Yes, sir.
So statement one and statement one is true, and statement two also will be true. But the point is whether there is a relation between those two or not.
Yes, sir. That I'm not understanding.
Yes. Why? Because why the quicksand condition occurs on downstream is due to the upward component of seepage velocity only. So
Yes, sir.
both are true.
Sir, but answer is given B, sir.
Okay. The possibility of quicksand condition occurring is more on downstream of a weir on a permeable foundation. Yes, both are true. The seepage lines. Okay, fine. See, seepage lines ends with an upward component of seepage velocity at the downstream. See that. On
Yes,
the
sir.
downstream side, the seepage only, upward seepage only. But when does the quicksand condition occurs?
When both are equal. When
When both are equal, then only they are going to be same. Understood?
yes, yes, sir.
So when the upward pressure equals to submerged pressure, then only quicksand condition occurs. So statement one number true, means statement two is true, but both are not going to be, means statement two is not the exact reason. The exact reason is upward pressure should be there and it should be equals to downward pressure. Okay?
Okay, sir. Sir, in CRPQ, sir.
No.
CRPQ 8th chapter 10th question, sir.
Yes, tell me.
Sir, in this 10th question, sir, actually I am getting F is less than 1, means failure condition I am getting, sir.
Failure.
Failure. Sir, in answer it is given quicksand will occur.
Yes, that's what. Now, quicksand occurs means when factor of safety is less than or equals to 1, quicksand occur.
Okay, sir. Yes, sir. Okay.
Yes.
Thank you, sir.
Okay, man. Mr. Subhan, please speak out.
Hello, sir.
Yeah, Mr. Subhan, please speak out.
Sir, good afternoon, sir. Sir, can you please open ESC previous questions permeability chapter?
Yes, tell me.
Question number 22, sir.
Okay, fine.
Sir, in that we can use Q is equals to KIA, right?
Yeah, Q is equals to KIA, but with a drawdown of 2 meters and head is means drawdown means fall of water level. Head is 2 meters. They did not give you the length, so you have to take it per unit length.
Okay, 2 meter per unit length is head. I.
Yes, I value.
Okay, sir, come to 26th question, sir. 26th.
Yes.
26th, the flow is horizontal and uniform at all points. Flow is horizontal.
See, we assumed in the case of the permeability Darcy's law, whatever the assumptions he made is when the flow is horizontal and uniform at all the points in vertical section. The meaning of this one is, and it is uniform at all the vertical sections means then it is going to be homogeneous and isotropic.
Yes, sir.
Hello?
Yes, sir. Hello, sir.
It is going to be homogeneous and isotropic. According to Darcy, so flow is assumed as homogeneous, right?
Yes, sir. Yes, sir.
So that's the reason why we say it as flow is horizontal and uniform at all points in vertical section.
Okay, sir. Sir, 28th question, sir. Same chapter. Sir,
an extended layer of soil with the homogeneous rounded grains has a 10% of material finer than 0.07. What is the meaning of 10% finer than 0.07? D10, right?
D10, yes, sir.
Yes. The constant to be adapted to determine its permeability has been recommended as 750. I told it clearly in our class. If the constant means the relation between K and D10, if the constant is 750, then K is equals to 100 into D10 square. Yes.
100 or 750 into D10 square, right?
Yes. Then there in that equation, the D10 is going to be mm, and
yes.
K should be directly comes as meter per day.
In the notes, I have written like meter per second. K is equals to meter.
No, meter per day. Meter per day. Is shared as meter per second?
Yes, sir. You told it as meter per second.
I don't think so, man. Let's see that.
Yes.
Okay, fine. I have represented as meter per second. Okay. Yes. This is not meter per second. This is meter per day. Okay, fine.
Okay, sir. Last doubt, sir.
Yeah. This is meter
Sir.
per day. That's my bad, but my mistake. This is meter per day.
Okay. And one more thing is, if IP less than 7, it is low plastic, right?
Yes.
And if IP is in between 7 to 17, medium plastic.
Yes.
So if IP is equals to 7, can I take medium plastic, right? We take
So
medium
if
plastic.
if IP is 7, you can take it as medium plastic.
Sir, okay.
Okay.
Sir, thank you, sir.
Yeah. So meanwhile, some of our students. So will 75 mm size particle pass through sieve size of 75 from 75 mm? Yes, they will be sitting exactly over there. If you make sure, see this type of questions are, will 75 mm size particles pass through sieve size of 75 mm? See, if the size of the 75 mm and particle size both are same, then if you push it, then there is a possibility it can pass through 75 mm. See, one of the anonymous identities are determined unit weight of sand after measuring a water table for given question. A 10-meter thick bed of sand is underlain by a layer of clay of 6 meters thick. See, my dear student, you please send it to me to my mail. Those who has said that the total question you have posted. So you please send it to my mail so that I can answer that. Sir, in CRPQ question number 1, can we eliminate option D because of 0, or is there any condition where stress can be 0? You can eliminate option directly 0. No, you don't eliminate the option because the value should be there. You have to find out the values. So don't eliminate that. So Miss Sai Nikita and sir, can you explain the difference between the previous year ESC 8th chapter 9 and 18 question? 8th chapter 9th and 18th question. So just now I have been explained that. Okay, Miss Sai Nikita, I understood your doubt here. So the possibility of quicksand condition occurring is more on the downstream of a weir on a permeable foundation. Yes, that is assertion true. And reason seepage lines are directed upwards at the downstream side of such a weir. See, yes, according to the statements over here, assertion and reason both are true, and R is a correct explanation of A. So here the point is that they're asking more. The possibility of the quicksand condition occurring is more on the downstream of a weir on permeable foundation. Yes, there is a possibility. Then what is the reason behind it? Is the seepage lines are directed. Actually, question number 9 and question number 18 has the same answers. So one of the student who has talked with that. So you have asked one question. I think Mr. Aditya. Mr. Aditya, for the question number 18, the option should be A, it's not B. For question number 9 and for question number 18, the option should be A, it's not B. So you please go through that. Now next, Mr. Amit Chavan, please speak out. Mr. Amit Chavan, please speak out.
Hello.
Yeah, Mr. Amit Chavan, I am not hearing you. Please speak loudly.
Hello.
Yeah, tell me, Amit.
Sir, previous gate chapter question number 1, 2 marks.
Let me see once.
Hello.
Yeah. That question. 1 minute. Previous gate. Tell me.
Chapter 8.
Chapter number
8.
8.
Yes. 2 mark question number 1.
2 mark. Question number 1. Yeah, please. What is the doubt? Hello. What's the
Yes,
doubt? What's your doubt? What's your doubt?
Sir, in this question we have to use a capillary concept.
What capillary
Yes,
concept?
surface tension.
What is the cap?
Surface tension.
Not surface tension. Where did I mention capillarity or surface tension in chapter number 8? Did I mention anything over there? You see,
No, sir.
please go through the. You see, I'm telling you, you please go through the question number 1 in our material. You can understand that. See, the solution I will be explaining over here itself. A clay layer of a sand of thickness 12.5 meters is underlain by a sand. Okay. So this is a clay layer which is underlain by a sand, and the total thickness of the clay layer is going to be how much? 12. Yes. The gamma sat of the sand is going to be clay is going to be 18.5. When the depth of an open excavation trench reached 8 meters, see, when you reach 8 meters, then the bottom is going to be cracked and water starts to enter. The height to which the water would have risen from the top of the sand in a borehole, if it was a drilled pier. See, this is nothing but a clay underlain by sand means, then this is nothing but artesian pressure.
Artesian. Yes, sir.
So whatever the upward is artesian pressure, the downward is going to be the total gamma sat into Z, right?
Yes, sir.
You please equate it. Gamma sat given as 18.5 into zeta. See, out of 12.5, you removed 8 meters. Then what is the depth over here? 12.5 minus 8 is equal to 10 into H. Yes. So now you tell me 12.5 minus 8, 4.5. 4.5 by 10, 18.5 into 0.45 is equals to HA. Find out this HA value, 18.5. I don't want to use any calculator. So 18.5 into 0.45. So 18.5 half is going to be 9 something, and 18.5 into 0.45, I think the answer is going to be 8.3.
Yes, sir.
Yes, the what is there in that? Just simply total stress,
Number 5.
artesian pressure. You please go through the notes. I explain these conditions clearly, okay? Understood?
Yes, sir.
Yeah, okay, Mamit.
Yes, sir. And sir, I have another doubt.
Okay.
Sir, next chapter, question number 5.
Next chapter, question number 5.
2 marks.
क्या हो गया?
Yes.
क्या हो गया? बताओ. Tell me.
Sir,
what
in
happened?
this question, sir,
Tell me.
question line below sheet pile.
What?
Sir, whether we have to consider this line or not.
Yes. That is equipotential line only. That's equipotential line only. This is whatever. This is not nothing but this is equipotential line only. Drops 1, 2, 3, 4, 5, 6, 7, 8. 8 drops are there. Okay.
Okay, sir. Thank you.
Yeah.
Okay, sir. Thank you, sir.
Yeah. Okay. Okay. Fine. So next, Mr. Miss Pooja, please speak out. Miss Pooja, please speak out.
Hello.
Pramod, Mr. Pramod, please speak out.
Good afternoon, sir.
Good afternoon, Pramod.
Sir, I have one doubt regarding with phreatic line.
Yeah, okay, tell me.
Along the phreatic line, pressure head is 0.
Yes.
Can you please explain, sir? How is it possible?
Phreatic line is nothing but water surface.
Yes, sir. Definitely.
If you keep inside a piezometer or water surface, does water level rise into above the piezometer?
No, sir.
When there is no water level rise in the piezometer, then what is the pressure head?
0, sir.
Then what is the pore water pressure?
0.
That's it.
Yes. One more thing, sir. From CRPQ3, seepage analysis.
Yeah, you tell me the question.
CRPQ3.
Yeah. Means
Yes. If the A point is given on phreatic line, then what is the potential head, sir? If pressure head is 0.
Pressure head and potential head, that is different now. Potential head means hydraulic head, right?
Yes, means datum plus pressure head, na, sir?
Arey Baba.
Sorry, piezometric head.
See, hydraulic head means seepage head.
Okay.
Seepage head is a difference between water levels. It's not depends upon piezometric head or something else, okay?
Okay. And if the A point is given on phreatic line, then what's the answer will change or not?
That point A is lying on the same equipotential line, right?
Yes.
See, if they ask a pressure head on periodic line, that is 0. But there is a seepage head over there. Because with there is no seepage head, then there is no flow, right?
Okay. Then answer will be, sir, for that?
Then the same point, as A point is lying on the same equipotential line, answer is going to be same.
Okay. Okay, sir.
Okay.
Thank
Yes.
Okay. Thank you, sir.
So you can call periodic line as equipotential line. No, never don't call periodic line as equipotential line. Next, Mr. Anvesh. Mr. Anvesh, please speak out. Mr. Anvesh.
Sir, good afternoon, sir. Sir, my doubt is irregular load area. In that one point is there, sir. For scaling line, depth of chart should be equal to the depth at which stress to be calculated. Can you explain, sir?
What's the doubt?
In irregular loaded area.
Yeah, I understood that. Then what is the doubt? Why they are taking like that? That's what your doubt?
Yes, sir.
That's the mention of the Newmark chart, Nana. The Newmark chart line depth is, if you want to use the Newmark chart, then you have to convert any loaded area into some scale, and that scale should be equivalent to the line depth of the Newmark chart. Okay, that was a proposed one. That's not just I took.
Sir, first we irregular area can plot on the transparent sheet and go to the Newmark chart, sir.
Yes. First we
so
have
we can
transparent sheet. Then only we can apply into the Newmark chart.
We can find out that how much depth we can got to from the sectors also, sir.
Yes.
Okay, sir. Thank you, sir.
Yeah. Question number 11 on chapter number 10. So my dear student, anonymous, see the question number 11 of chapter number 7 in ESE. Actually, that answer should be 8 meters. That's not 4 meters. There is no given option. So if you just directly apply those things, then you can find out the value as 8 meters. Miss Aparna, please speak out. Miss Aparna.
Sir,
Good afternoon, Aparna.
I have doubt regarding previous ESC question, sir.
Yeah, come on, speak out. What is the doubt?
Sir, in second chapter, 10th one.
10th question. Just tell me. Value of per soil sample in which the total volume of soil grains is equals to twice the volume of voids, which means the volume of soil grains means volume of solids.
Okay, sir.
Okay, I think you might read as a V. It's not V, it's Vs. Volume of solids, Vs is equals to 2 times of the volume of voids, Vv. Okay.
Okay, sir. In third chapter.
1 minute, give me a minute. I am getting one call, please. Give me a minute. Yes, Mr. Aparna, Miss Aparna, please tell me.
Sir, in third chapter, 10th one.
Desiccated means the clay in its dry state. Desiccated clay means the clay is a dry state. Okay. When the entire clay is going to be free of moisture, then we call it as a desiccated clay. At the same void ratio, desiccated clay is stronger than the saturated clay because so without changing the void ratio, the desiccated clay means a solid state, right?
Yes, sir.
The desiccated clay is stronger than the saturated clay, and the desiccation impacts must induce pre-compressive forces in the soil structure. See, when the entire moisture is going to be evaporates, what happens over there is so the particles are going to be induces some compressive forces that causes the clay into stronger one. Okay.
Okay, sir.
Yeah.
11th one, what is mean by friction ratio?
That reliable, let me see the question. Reliable friction ratio means a sleeve friction by tip friction that we will be seeing that in chapter number 19 or 20. We are going to discuss about the penetration test. There it will be coming, but it's not important now. So you please go through the remaining questions. Okay.
Sir, in fourth chapter, third.
If the water table is very near to the subgrade of the soil, it will ultimately cause the cracking to the road surface. You see, if the water table is very near to the side of the road, it will ultimately cause cracking of the road surface because if the water table is going to be very near to the ground level, there is a possibility of capillarity. And due to the capillarity, the water means the consistency of the soil mass will be decreases. Okay.
Yes.
And reason the consistency of the soil will change from plastic to liquid state, leading to its volumetric decrease. See, when the consistency changes from plastic to liquid, does the volume increase or decrease?
Increases.
Yes. So reason is false and assertion is true. So A is true, A is false.
Okay, sir. Yeah. Last one, sir.
Which one?
32.
Knowledge about moisture content is necessary to determine permeability. Some typical marine clays may have moisture content as high as 400%. Yes, typical marine clays as 400% for black cotton soil mass it is there. Knowledge about moisture content is necessary to determine the permeability. It's not of necessary actually.
But option given is.
Yeah. Let me see the options once again. Sand bath method of moisture content is determination is not suitable for soils containing organic matter. Yes, that's true. So 2 and 3 is true, but the knowledge about the moisture content is necessary to determine the permeability. Yes. Why? Now I tell you. See, I told you the degree of saturation, right?
Yes, yes, sir.
As the moisture content changes, the degree of saturation is also going to be changes.
Okay.
So more the degree of saturation, more the permeability. Understood?
Yes, sir.
So indirectly, this moisture is also going to be related to determine the permeability.
If moisture content increases, we can say degree of saturation also increases.
And permeability increases.
Okay, sir.
Okay.
Thanks.
Mr. Yash, please speak out.
Hello, sir.
Yeah, Mr. Yash.
Hello.
Yes.
My question regarding ESC chapter number 6. Question
ESC
number 18.
Question number
18.
Tell me.
Reduction in density cause apparent cohesion in sand. I don't understand.
Apparent cohesion in sands is exhibited mainly due to actually apparent cohesion you will be seeing in chapter number 13 shear strength because in the sands some part of the cohesion will be present when there is a moisture in the soil. So that we will be discussing the chapter number 13. So you don't know.
Sir, one more question.
Yeah.
Permeability decrease with increase in effective stress and dry density.
Yes. Permeability decreases with increase in the effective stress. What is the meaning of effective stress?
Stress, strength between solid particles.
One grain to other grain. Okay.
Mhm.
Contact between the particles is more, effective stress is more. Accept or not?
Yes.
When the contact between the particles is more, then the void space between the particles are less.
Okay. And
Then
dry
the
density.
stress permeability is less.
Okay. Okay. And dry density.
The dry density is the same thing. The particles contact is more, dry density is more.
Okay. And 26, same chapter.
Same chapter.
26, tangent magnitude. Sir, in this tangent magnitude is 10I or not?
Tan I and sin I both are same because whatever the value small slopes, tan I is value, tan I is equals to I, right?
Okay. Okay. Sir. Clear.
Sir, how could you find a pattern of loading, whether it is a regular or irregular? That is from the plan view you can see, Nana. So with this, I'm going to stop today's session. Already I have taken around 45 minutes or 50 minutes of doubt clearing session. So with this, I'm stopping the today's session and we'll be meeting tomorrow. Not tomorrow, day after tomorrow. So there is no class tomorrow.